Hello and welcome to this video. Python is a general purpose programming language. This means it can be used to write computer programs for various things like games, data science, websites, and so on. Python is also a high-level programming language. High-level programming languages mean that the languages of writing computer instructions in a way that is easily understandable and close to human language. Python is portable, which means we can run Python programs in the various different operating systems like Windows, Mac OS, Linux without any changes. Python is an interpreted language. Python is called an interpreted language because it goes through an interpreter which turns code you write into the language understood by your computer's processor. Python is strongly typed. Strongly typed languages don't convert data from one type to another type automatically. Python has a huge set of libraries. A Python library is a collection of programs you can incorporate into your own program without writing code for them. Let's take a look at a list of application types you can create with Python. Web applications. These are applications you can access using a web browser. Android applications. These are applications that runs on Android devices like Android phones and tablets. Games. You can create various types of games with Python. Scientific applications. You can create various types of scientific applications with Python. System administration applications. So you can use Python to create applications to monitor various types of systems. You can also create console applications. A console application basically is a computer program designed to be used via a text-only computer interface. Let's take a look at a list of software applications that have been created using Python. So some of these are quite famous and popular. First on the list is YouTube, and then we have Google, we have Dropbox. This program lets you save files to a cloud-based service that you can then access from anywhere in the world. We've also got Reddit. Reddit is one of the biggest open communities on the web. You have a question you want to talk about, something in specific, or if you want to find tons of information regarding a particular topic, for example, gardening or anything, you can just look on Reddit and find related information. Next, we have Spotify. Spotify allows you to listen to ad-free music of your choice. It's a streaming service that allows you to stream music without any advertisement. Finally, we've got Instagram. Instagram is very popular. It has both an app side and also a web site as well. These are just a few list items of software that were created using Python. There are so many others, but these are just some few that you may have come across. How to download and install Python on Windows-based computers. To check if Python is installed on your computer, you need to open up the command prompt and type in the following command, which is Python space -- version. I have got my command prompt open, so I'm going to type in the command Python space -- version, and then you press enter. You should get this message displayed saying Python is not recognized as an internal or external command. This proves that you haven't got Python installed. So I'm just going to exit out of this command prompt by clicking on the X, and we have the website for Python. So this is the official website to download Python. The link is displayed on the screen. That will give you access to the download page of Python. So click on the Downloads tab, which is this tab here, and the current version as of the time I am recording this video is Python 3.72. Next, you can click on the button that says Python 3.72 to begin the download. So click on that and the download should begin. So you can see the download here on the bottom left hand corner of the screen. So we'll give that a few minutes to complete the download. The next thing we're going to do is install Python from the downloaded file. To begin the installation, on the bottom left hand corner is the downloaded file. Just click on it to run the Python installation and you'll be presented with this screen. I'm just going to minimize the other screen so we can see the installation screen properly. The setup screen provides some information as to where Python is going to be installed, which it tells you this is where it's going to be installed for me. It also tells you what else is going to be installed. So it says it's going to install idle and it's going to install pip. Next, on the bottom here, we've got a box that says add Python 3.7 to path. Make sure you click inside that box to make it checked, and then once you've got that box checked, click on this install now button to begin the installation. So click and that should start the installation. Once the installation is finished, you will get the message saying setup was successful. You can just click to close the setup box. Next thing we want to do is check that Python is installed. To check that we have definitely got Python installed, we need to type in the following command inside the command prompt. So you type in Python space, you do -- version, and then you press enter. And that gives you the current version of Python. You can see it displays version 3.72. How to install Python 3 on a Mac. By default, Python comes pre-installed with all Macs, but the version is quite old. So it comes pre-installed with version 2.7. The current versions of Python being used is Python 3X. So let's open up our terminal to check the version of Python that we have installed. So this is my terminal. So you type in Python, you do a space, -- version, and press enter, and that gives you the current version installed on your Mac. So this is a version that comes pre-installed. It is possible to have both version 2 and 3 installed, so version 2 and 3 can coexist on the same machine. So let's go over to the official Python website and download Python version 3x. X meaning the current version. As of the time of recording this video, the current version of Python, if you go to downloads, it gives you the current version. So the current version is 3.7.2. all right, so to begin the download, just click on the button and it will just drop the download in the download folder. We give it a few minutes to complete. You can see it here, it's downloading. So once that blue bar is completed, we know that it has completed the download. So just give it a few minutes to complete. So once the download is completed, you can see here it gives you a little brown box on the bottom. Just click on the brown box and it shows you what's in there, which is a PKG file. So it tells you open in Finder. So click this to open it in Finder. Now this is what was downloaded. So just double click on it and that will launch the installer. So I'm just going to minimize everything else so that we can have access to the installer screen. So feel free to read through what's on the screen. Click continue. You can scroll through and read through all this. It just gives you some important information about the version. Click continue and you can check out the history and the license if you've got time to do that. Otherwise, click continue and you need to agree to the license agreements before you can progress with the installation. So click agree and click install. It will prompt you for your password. So enter your password and click install. And you can see here it started the installation. So I'm just gonna give it a few minutes to complete the installation. Installation is complete. So these are all the stuff that it basically installs. So when you install Python, it also installs all this, the idle and everything else. So I'm just going to exit that at the moment. It's just telling you what it has installed. And then here it tells you the installation was completed successfully. Congratulations, Python 3.7.2 for Mac OS 10.9 or later was successfully installed. So feel free to close the box and it tells you here, do you want to move the Python installer to the trash now that we've completed? I would say yes, move to trash because we've done the installation. Next thing is to open up the terminal and let's check for the version of Python. So to check the version of Python that we have installed, we need to type in Python 3 and do space -- version. If we typed in just Python, it will return Python 2, which we don't want. It tells me I've got Python 3.72. If we were to just type in Python and do a space -- version and press enter, it gives you version 2.7. So it's very important when you are trying to develop or create things in Python, you have to use the correct version of Python that you are referring to. For example, if I wanted to do something interactive and I typed in Python, it to give me the Python shell. And I can do simple maths. I'll do 6 plus 6. I press enter. It gives me the answer of 12. Now, if I want to exit, this is called the Python shell. If I want to exit that, I type in exit and parentheses, press enter, and that will exit the shell. If I need to clear my screen, I type in clear, and that clears the screen. Now, if I want to access Python 3 shell, I type in Python and then 3. If you notice, it tells me here, Python 3.7.2. So very important to type in the correct version of Python when you are trying to develop or experiment. So again, we can do a simple math. I do 8 plus 7. It gives you 15. So we just exit, type in exit, and then the parentheses, and that will exit the Python shell. So this concludes the installation of Python 3 on a Mac. Thanks very much. If you had any problems during the installation, please feel free to let me know. I'll be more than happy to help out. How to download and install Pycharm on a Windows-based computer. What is Pycharm? Pycharm is a Python IDE. IDE stands for Integrated Development Environment. So Pycharm can be used to create applications that are written in Python. It allows you to write, to run, and test your application from within the IDE. Pycharm is widely used by Python developers. It is cross-platform, which means it can be used on a Windows, a Mac OS, or a Linux-based computer. Pycharm is developed by a company called JetBrains. Pycharm can be downloaded from the link displayed on the screen. To download Pycharm, you need to click on the download button, and that will give you two options. You've got the professional and the community. The professional is a full-featured IDE for development and can be used on a trial basis before you pay. But eventually, after your trial expires, you'll be expected to pay for it. We've also got the community version, which is a lightweight IDE that can be used for Python and scientific development. So that is the option we are going to go for. So I'm going to click on the download button to begin the download for the community. You can see the file here being downloaded on the bottom left-hand corner of my screen. Next, let's install Pycharm from the file that was downloaded. So the bottom left-hand corner is the Pycharm file that was downloaded. So I'm just going to give it a click to run the installation file. So give it a few minutes and it should pop open a screen. You may get a user account control, and just click yes or click run, and that will give you this setup screen. Click next and just accept the destination. It tells you the space required, the space you have got. Click next. All right, and then you can create a shortcut on your desktop if you wish to do so. So you have a 32-bit launcher or a 64-bit launcher. So I'm going to click on that to create an icon on my desktop. You can also update the context menu if you wish to do so, but I'm only going to leave that. You can also update the path variable if you need, but if you click that option, you will need to restart your computer. So I'm going to leave that for now, and I'll click next, and I'll click install. and that should begin the installation. So you can see here is dropped the icon on my desktop, so we wait for it to complete the installation. Once the installation has been completed, you get the screen saying completing Pycharm Community Edition setup. So you can either run it by checking the box or you can finish. So I'm just going to click to finish, and that is my icon. How to download and install Pycharm. Pycharm is a Python IDE. IDE stands for Integrated Development Environment. It's a tool that has all the tools that you need to develop various types of application. We are going to download Pycharm from the JetBrains website. JetBrains are the developers or the makers of Pycharm. So let's go over to the jetbrains.com website, and they also have other tools, not just Pycharm. In this video, we are going to focus on Pycharm. So these are all the IDs they do. So I'm going to click on Pycharm to take us to the Pycharm page. And once you're on the Pycharm page, just click on download. Pycharm comes with two versions. So we have the professional version, which is fully fledged. This is paid for, but it also allows you to try it out for a while. And then we have the community version, which is lightweight, but is completely free. So I will be downloading the community version. So just click on download to begin the download. So we'll give it a few minutes, and that should start the download, and the download should have started. You can see this is the download bar. So once that bar completes to the end, that means it would have downloaded it, and then we can go ahead and run the DMG file, which will enable us to copy the Pycharm application into our applications folder on our Mac. Once the download has completed, you should see that in your downloads folder. So if you click on your downloads folder, it tells you the name of the file that was downloaded. So let's open it in Finder by clicking on this, and that is the downloaded file. So I'm just going to minimize this other screen so we can see the screen properly. So I'm just going to double click to extract the DMG file, and once that is extracted, we should be able to just drag it into our application folder. Just going to double click again to make sure. All right, so it's doing it now. Just give it a few minutes to complete. So it's completed the extraction. We just need to drag this into the applications folder to complete the installation. So I'm just going to drag and drop. It says copying it. So that has completed. I'm just going to exit. Now, if I open up Finder, we should be able to go to the applications folder, and you can see we have Pycharm CE. CE is a community edition. Walk you through some basic configuration setup of Pycharm on a Windows-based computer. When you launch Pycharm for the first time after installation, you should get a screen like this that asks you to import Pycharm settings. This usually happens if you've got Pycharm installed previously and you are installing maybe a different version and you've got some settings saved. By default, you should have do not import settings check. So make sure that setting is checked, and then just click OK to progress to the next screen. So this is my Pycharm icon. I'm just going to click on it to launch it. So the very first screen you get is the previous screen I showed you. Once you've got that, it then presents you with this screen here. Just click the box that says I confirm and click continue. If you click reject, it will exit. So make sure you click continue. and that will give you this screen on data sharing. Just click don't send. So it's asking you to send some data on your usage. So for now, click don't send, and it then tries to launch Pycharm. So get a few minutes to launch. Once it launches, we can begin the basic configuration setup. Pycharm is a very powerful IDE for Python, and it has lots and lots of stuff in there. So we're just going to focus on the very basic configuration settings to get you up and running with Pycharm. So this is what you get. Click on this configure option here and click settings, and we just wait for it to come, and then you get the options like this. So this is the settings page. On this page you can change different things. You can see we've got appearance highlighted. This is the appearance interface where you can change stuff. This is the default theme, which is the background color. You can see if you want to change, you can change that. Say for example, I want a darker theme. I'll click on that, and that will give me a darker theme. So if I click apply, you can see the theme has changed to a darker view. So there are different configuration settings here if you want to do different things. If for example I've got the editor here, the editor is where you write your code. There is an option here called font. If I wanted to change the size of my font, if it tells you here this is the current size, if I wanted to change it, say for example to 20 in size, and it gives me what it will look like. So again, I can accept that, and there is an OK button here. I just click OK to accept that setting. I have not quite finished with the configuration. I need to go back in and click settings, and what I want to do next is set up the project interpreter. The interpreter is very important. It is what interprets the code you write into a code that the machine can understand. So I'm just going to move this up a bit so you can see here. And the bit I'm interested in is this bit here that says project interpreter. So I'm going to click on it, and that will give me this interface. So here you can see here there's no interpreter selected, so I need to add an interpreter. So you can see I've got a drop down here, there's no interpreter. So here in this sign here, I can click add to add the interpreter. So you can see here is giving me some suggestion of where the interpreter could be. I've got Python 3.7, so it's pointing to that directory, so I want to accept that. So I don't want to use a virtual environment, so I'm going to click on System Interpreter. All these settings can always be changed later. So it's got my interpreter selected as that, Python 3.7. What that means is that any code I write will be interpreted in this version of Python. All right, so I'm happy with that. I'm going to click on this OK button, and that will try to load the package list that I can use with the interpreter. So it's giving me, I'm going to be using pip and setup tools. So once I am happy with that, I'll click on the OK button here, and that will start updating the Python interpreter. Once the interpreter has been updated, you're back to the welcome screen here. You got option to create a new project, to open a project, to check out from version control. So I'm going to click this button to create a new project. Click on that, and it gives you the location. This is very important, where your project will be stored. It gives you a default name of untitled. So I'm going to change that untitled and just type in Python course. You can type in whatever name you like. And then here under project interpreter, I'm going to click on that to expand it to make sure I've got the interpreter I need. it says new environment using virtual environment. I don't want to use a virtual environment at this moment, so I'm going to check this box that says existing interpreter. So it's going to use this interpreter that I have, which points to where my Python was installed. I'm going to click create, and that will create the project. So once the project is created, you get this screen that says tip of the day. This screen pops up every time you launch Pycharm, and there's a checkbox here. If you don't want it to show up, just uncheck it. But I recommend you leave it because it might have some useful tips. You can just close it for now. And this is the interface you get. That's the project that has been created. So I'm going to end this part of the video here, and we'll continue in part 2 where we will create a Python file. We'll continue from where we left off in part 1. Pycharm has an integrated text editor that allows you to write Python code. So we're going to create a Python file and just write maybe one line of code just to test it out. So to do that, where I've got my project name, that's where I want to create the Python file so that it is contained inside that directory. So I'll right click, and there's an option for new, and there's option for new file. But what's more important, we want a Python file. So we click on that option for Python file. We'll give it a name. I'm going to call it greeting, and it will automatically save that as a Python file. So I'll click OK, and you can see here it's created the file greeting.py inside my project directory called Python course. So this is the editor area. This is where I can now write my Python code. So I'm just going to write just one line of code here. I'll do print, I do parentheses, and I do my quotes. I just say hello world. All right. And that is basically my line of code. This is a complete statement, complete valid code. So to save that, I do a Control and S, or I can come here and do file and just click save as, or just click save. There's an option on the bottom here also that says save all. So there are various ways you can save your work. Now, this file here is a file that I can execute inside this integrated environment inside Pycharm. I don't need to leave Pycharm to run this file. So to run this file, there is a play button, but the play button is not automatically activated. So to do that, here on the left where I've got the name of the file, I'll right click, and there's an option to run the file. You can see the name of the file here. I click run, and that will execute inside this area here. This area here, you can see the code here. This line of code I've written here is being outputted inside this area here. This area is called the terminal or the console. Okay, some people call it console, some people call it the terminal. So this is where the code outputs. Another thing to take note is this line here. It tells you the location of the file. So if, for example, I wanted to run this file outside of this integrated environment, I can just browse to the location of this file and then just run it directly in my command prompt or my terminal outside of this Pycharm integrated environment. Another thing I want you to note is that you notice that this play button now is now active. So if I want to run this file on future occasions, I don't need to come here and right click. I can just click on the play button because it's now selected here in the list. If I have other files I create, I will also have them listed. I can go there to make sure they are there and then click on the play button. Also integrated inside the Pycharm, we've got the Python console. Python console is different from the terminal, is the interactive shell. So if I click on it, you'll see the symbol here. You can see it's the interactive shell that allows you to interact with Python. So the Python console is the Python shell, while the terminal is actually where the code is outputted. The difference within the Python console and the terminal is that with the Python console, you interact. You type in a line of code, you get a response, and so on. Whereas when you are working with the terminal will just output the line of code. For example, here, if I run this code again, all it does, it just gives me the output for the line of code. So there's a key difference between the terminal and the Python console. Let's say I want to run my Python file outside of my Pycharm environment. I can just go to the location of the file, which is indicated here in my terminal. So I've just got it here. So it's on my drive. That's it here. It's got a folder called Pycharm projects. And inside that, I've got the project called Python course, which is that. And inside that Python course, I have got my file, which is called greeting. So if I want to execute or run this file outside my Pycharm, I can do that. I will just navigate to this location. This is it here. I have navigated to the location. It's in this directory here. You can see I've changed directory to Pycharm project, which is this directory here. And then I've also changed Pycharm project is where your projects are stored in Pycharm. So you locate that directory, and inside that directory, you can see I've changed directory to this directory called Python course. And it's inside here that my file greeting.py is. So if I want to run that file inside my command prompt, which is outside the Pycharm IDE, I just come here and type in the name of the file, which is greeting.py, and press enter, and that should execute. You can see it's executed the code here, and that's the same thing it has done when you run it inside the editor. So if I click on play here, it does the same thing here, that I'm able to run inside my command prompt, which is outside the Pycharm environment. So it's very important to know the location of the file in case you want to run that file outside the Pycharm integrated environment. So this concludes the two-part video series on basic Pycharm setup configuration on a Windows-based computer. Note this is just the basic configuration settings because Pycharm is very powerful. There are other stuff you can set up inside it, but to just get you up and running, we've done the very basic. Feel free to go through the help menu inside Pycharm and read through more about other things you can do with it. To begin the configuration of Pycharm, you need to open up the Pycharm application from your applications folder. So this is my applications folder and this is Pycharm. So I'm just going to click to launch Pycharm. So when you launch Pycharm for the first time after installation, you may get this message pop up. Just click open, and that should begin the launch of Pycharm. So you may get this option that comes up asking you to import settings. If this is the first time you are setting up Pycharm, there will be nothing to import. So just click OK, and it gives you this licensing agreement. Just click on the box that says I confirm that I have read and accept the terms of this user agreement. Once you've done that, click continue, and you get this option here. If you want to send information, just click don't send. So you get this interface about the key map scheme, and you have two options here. I've never used Pycharm before. I used Pycharm before, so I'll leave the default checked and just click next. You can click to skip if you wish to do so and just accept all the default settings. So I'm going to click next, and here it's talking about the UI theme. A theme basically is the background of the Pycharm. If you want a lighter background, this is how it will look. If you prefer a darker theme, which is checked on default, you can leave this darker theme, but you can always go back to change it later. It tells you where you can change it in the preferences, under appearance and behavior, and then in the appearance bit you can change the theme back if you want to switch. For now, I'm going to accept the default theme and click next to launch script. Now basically it's asking you to create a launching script. Create a script for opening files and project. If you wish to do so, you can. If not, you can skip it. At this point, I'm going to click skip and accept, skip remaining and set the default, because from now on it's not really that much to do. You can always go back and change stuff later. So I'm going to click on that, and that would begin the launch of Pycharm. So when you have this Pycharm screen launched, first thing you want to do is configure. So click on this configure button here, and under the configure there is an option for preferences. So click on preferences. Okay, and under preferences there's a lot of things you can do here. Again, if you want to change the theme, that's where you can change it. If you don't like the dark one, you want to go light, just click on the drop down and you have the option to change. There are different things you can also change here. Okay, so you just feel free to look through at your own convenience. But what I want to set up here is the interpreter. Interpreter is basically what we interpret all the code we write so that the computer can understand. So we need to set that up. So click on here where it's called project interpreter. Now there is an option. If you've used it before, it'll give you the options. If you click on the drop down, it will have the interpreter, but because we've just setting this up for the first time, we need to select where the interpreter is. So normally you can select this from the directory where Python was installed. So click on this option here, and that will click add, and that will kind of like give you this option where you can browse to where Python was installed. So it's telling you here you can use the base interpreter, which is located in this location here, which is Python 3.7. Now this I want to use the base interpreter. If you've used Pycharm before, you can use the existing environment. Also here there are other options here. There is inherit, global and site packages. So if you want a package that you add to be inherited globally throughout your computer, you can do that. You can make available to all projects. I'm going to leave this option unchecked for now because I don't want to tie down to anything. You can always go back there later. Notice here we've got virtual env selected. If you want to create a virtual environment, so I'll leave that for now. Don't want to complicate things. So click on system interpreter. So this is the interpreter I want the system to use. You can see the interpreter is selected is Python 3.7. I'm going to go with that. I'll click OK. All right, and you can see it's setting everything up. So now we've got the project interpreter. So anytime we are creating a project, it's going to interpret it using Python 3.7, and these are other stuff packages that is going to use as well. So once you're done, just click OK. So that's the interpreter setup. We'll wait for it to finish updating the Python interpreter. Once that has finished updating, it will then give you back the original screen where you'll have an option to create a new Python project. So I give this a few minutes to complete. So now that has completed, you back to the original screen here. Now we can go ahead and create a new project. So click on this button to create a new project. You have to give the project a name, and it tells you this is the location where the project is going to be stored. So I'm just going to remove the default name, which is untitled. I'll just call it Python course. All right. And project interpreter, click on this drop down here to select the interpreter I'm going to be using. I will be using this one here, existing interpreter, which is Python 3.7. That's the one I have checked. I'll click create. Okay, and that will create the new project. You will get this welcome screen. Feel free to read through. If not, just close. You get this each time you open Pycharm, unless you uncheck this option here not to show it. So click close, and here basically you've got the project that's been created. Next thing I want to do is create a Python file. So to do that, you just right click on this project that I created called Python course. Right click, go new, and there's an option for Python file. So create that. I'm just going to give it a name. I'll call it greeting, and it will save it with a .py extension because it's a Python file. So I'll click OK, and that will create the file. You can see it's created a file here called greeting.py, which is here. So I'm just going to type in a simple code here. I'm just going to say print, and inside that print parentheses, I'm going to just say hello world. I got a double P here. Need to get rid of one of the P's. All right, so that effectively is a complete Python statement. Just one line of code here to say hello world. So I'll save that. I just do Command and S. If you're on a window, you do Control and S. So now that has been saved. To run that, we've got a little play button here, but that play button is not activated the first time. To activate it, you need to run the file from here. So right click on the file that says greeting.py, and there's an option here that says run greeting. Okay, so click run, and you can see here this area here is called the console. All right, or the terminal. You can see it's outputted this line of code here inside the terminal. This area here is called the terminal or the console, where you can output the code that you run from within the editor. This area here also has the Python console. Python console is different from the terminal. The Python console is basically the Python shell. So if I click on this now, you can see the shell. This is the interactive shell. So if I say 2 + 2 and press enter, it will return 4 because this is an interactive Python shell. So I'm going to click on this X to close the console, and this area is the editor area. See, now that we've run the code the first time, anytime we want to run it again, we don't need to right click on this. We can just go here. You can see the file is highlighted here. If you have multiple files you want to run, you can click on the drop down and then select which one you want to run. At the moment, because we've already executed this file, it's showing up there. So if I want to run it again, I just click on this play button, and you can see here it displays here. Notice also here it tells me the path where this file is stored. So if I wanted to run this file outside of this integrated development environment inside Pycharm, I just go to this location here, grab this file, and then run it from my terminal. All right, so it's very important to know the location of the file. So this file here, greeting.py, is located in this location. Hello and welcome to this introduction to text editors. What are text editors? Text editors are computer programs that enables you to write and edit plain text. Text documents mainly come in two flavors. You can either have a rich text or a plain text. With a rich text, you can format it, while a plain text is rather plain. You can't really do much with it. With a rich text, you can format the text with bullet points and so on, but you can't do that with a plain text. The text editors that programmers and developers use are usually plain text editors. Major operating systems like Windows and the Mac are shipped with a free text editor. Windows ships with Notepad, which is free, comes built into the system. If you're on a Mac, it comes shipped with Text Edit. Text editors can also be cross-platform. That is, they can work on most systems like Macs and Windows. So they are not confined to one. They will work on multiple operating systems. Let's take a look at some very popular text editors that are cross-platform. These are popularly used by developers and programmers. They are not in any particular order of popularity. They are all modern plain text editor. So we have brackets, which can be downloaded from the link displayed. And if you want to know more about the editor, if you can refer to the link displayed as well. The brackets text editor is completely free to use. And then we have the Atom, which also can be downloaded and installed on the link address displayed. And if you want to find more about that text editor, you can also do that on the link displayed. It is also free to use. We then have Visual Studio Code, which is also free to use and can be downloaded from the link displayed. Also, you can find out more information from the link displayed. The next one is called Sublime Text. This is also a cross-platform editor. It is, however, not free to use. It will let you use it for a period of time, but it will then start prompting you to purchase the text editor. So it's not completely free, even though it lets you use it, but you will get a prompt from time to time after you've used it for a certain period of time to download and install the Atom text editor. What is Atom? Atom is a free, open source and modern text editor. By open source, I mean its source code is open for developers to contribute in making it better. The Atom text editor is cross-platform. That means it will work across multiple platforms like Windows and also a Mac. The functionality of the Atom text editor can be extended by installing various types of extensions. You can download Atom from this link, which is atom.io. The link takes you to the homepage of the Atom text editor, where you can download and learn more about the text editor. This is the homepage of the Atom text editor. To download, there should be a download button. Here you go. Depending on your operating system, if you're running a Mac, it will present you with the relevant download button. I'm running a Windows, so I'm going to click on this to begin my download. So that's the download there. I'm going to give it a couple of minutes to finish downloading. Then I'll run the installation files. The files are finished downloading. So I'm just going to double click to run the Atom setup file. So click, and it's trying to prepare the files for installation. We just give it a few minutes to get, there you go, it's trying to launch. So what's happening is the editor has been installed at the moment. You can see it tells you here Atom is being installed, and it will launch once the installation is completed. Once the installation is completed, it automatically also launches the text editor, and this is the default screen that you are presented with when you first install the editor. So you've got different options here. You can, for now, it tells you here that Atom is not currently set as your default handler. You can skip that and go back to it later. So just click on X. So this is the default screen, and in this palette here, if you wanted to extend the functionality of Atom by installing different packages or extensions, this is where you will go. So you got an option here to install a package. Atom has several packages or extensions that you can use to extend its functionality. As you begin to use the editor, you may come across useful extensions or packages that others have used, and you may want to install it yourself, and this is where you go to install that. If you want to choose a theme, if you don't like the default theme, you click on this button to change it. And if you want to integrate with GitHub, it integrates nicely, GitHub and Git, which is a version control system. And if you want to open a new project, there's a tab here to open up a new project. So that's it for the installation of the Atom text editor. I will introduce you to high and low level programming languages. What are high level programming languages? These are languages that only humans can understand. So computers can't understand them unless they are compiled or interpreted. They need an interpreter or a compiler for the computer or the machine to understand what the programming is trying to get it to do. Examples of high-level programming languages include Python, Java, C#, C++, PHP, Ruby, and there are many others. What are low-level programming languages? These are languages that only machines can understand. They do not need an interpreter or a compiler. They are closer to the computer hardware. Examples include machine and assembly language. This is a brief illustration of high and low level languages. So you can see the nearer the language is to the hardware of the machine, the faster it is, and it doesn't need to be interpreted because it's so close to the computer hardware. Whereas the further away it is, like we've got these lot here, they are further away from the hardware, so they're easier for programmers to understand because they contain English related words, but not machine to understand. So for the machine to understand what this block here is saying, it needs to be converted into machine code using a compiler or an interpreter. Key differences between high-level and low-level programming languages. High-level languages are easier to learn. Low-level languages are more difficult to learn. High-level languages are near to human languages. That's easy to read. They are like basic English. While low-level languages are far from human languages, so only machines know what they are talking about. You need a translator like a compiler or an interpreter, to convert a high-level language into machine language. No translator is needed for low-level languages because the machine hardware knows what they're talking about. Programs written in high-level languages are slow in execution because obviously they have to compile or interpret them, while programs developed in low-level languages are much faster in execution because there's no compiling or interpretation going on. The hardware understands the language, so it's easy or easier to execute the instructions. So these are the key differences between high-level and low-level programming languages. I'm going to introduce you to compilers and interpreters. What is a compiler? A compiler is used to translate the entire source code into machine language before the code is executed. So basically what that means is that the computer, for the computer to understand what it is you're trying to get it to do, you have to use a compiler to compile or convert your code into a code that the machine can read. All right, examples of languages that are compiled, that means languages you have to compile before the code is executed, includes C and C++. So let me illustrate how the compiler works. So let's say you have your source code, and your source code is basically your computer code that you write. So let's say inside the source file, you have this. You've got x equals 7, y equals 8, and then the sum is equals to x plus y. And then you want to print the value of the sum using the print function. Now, the computer will not understand this. So what needs to happen? You need to use the compiler to convert that code into machine code. The machine code is something like this, because computers only understand zeros and one. So the compiler compiles it into machine code, and then it executes the code. It then passes it on to the computer memory, and the computer memory then outputs the result, in this case, which is 15. So that's basically how a compiler works. Compiler will compile the entire code into machine code before it passes the information to the CPU to display the result. What is an interpreter? An interpreter does a similar job like a compiler. The key difference with the interpreter is that the interpreter will translate or convert one line of code at a time, okay, into machine language before the code is executed. Examples of interpreted languages include Python and Perl. So let me show you an illustration of how an interpreter would work. So let's say you have your source file and you have this bunch of code inside your source file. At this stage, the computer would not understand that. So for the computer to be able to interpret what you're saying, you need to use an interpreter. So the way the interpreter works is that it will convert a line at a time. So for example, it would do x equals to 7, compile that and run it. You'll do y equals to 8. It will translate or convert that and then run it. It does line by line, in comparison to a compiler that compiles the whole code into machine code before it executes. In case of an interpreter, it does it line by line, and then eventually it will produce the result. This is a brief table that illustrate some key differences between compilers and interpreters. Compilers basically will transform the entire source code, while interpreter will transform line by line of the source code. The compilers will generate a machine code first before it executes. The interpreter does not generate any machine code. Because the compiler generates intermediate machine code, it uses more memory. The interpreter uses less memory. Compiled languages run once. So once you've compiled it, you can run it anywhere because it's already been compiled. While the interpreter, the source code has to be interpreted each time you run the file. The compiler basically is more difficult, compiled languages, because it's more harder to find problems or debug issues, while the interpreter is much easier to debug. The compiler is faster and the interpreter is much slower. So these are some key differences between compilers and interpreters. When you are creating a Python file using a standalone text editor, it's a good idea and good practice to have a directory that you can place your file into. It makes it much easier to locate your files, and also it avoids cluttering your desktop or wherever you store the files. So I have got a couple of files here on my desktop that I created using a standalone text editor, and I've also created a directory here on my desktop. So by dragging the files to my directory makes it easier to locate my files, and also it doesn't clutter my desktop. So it's a very good idea. Now, if I wanted to access the files inside this directory, if I want to run any of them, all I need to do is change directory to where the files are and then call the file from that directory and access it. So this is how I would do it. You can see here on my command prompt, I've navigated to my desktop, and on my desktop, I've got this directory called Python files. Now inside that directory, I've got my files. So if I do a dir, it will give me a list of all the files inside that directory. So you can see here I've got 2 Python files. So all I need to do, if I want to run that file, I just call the file by its name. Okay, so for example, I've got a file here called my tuple. Now if I want to access that file, all I need to do, I call it by its name. I just say my tuple.py and press enter, and it will run the file. So it's very important to navigate to the location of the file before you can run the file. I'll be showing you ways of interacting with Python. The common ways of interacting with Python is via the Python shell or console. This is suitable if you are only writing a single line of code or a few lines of code. You can also interact with Python via a Python file. A Python file is basically a file that has a .py extension. So let's take a look at how we can access the Python shell or console. So we can access the Python shell via the command line interface, which on a Mac is known as a terminal. If you're on a Windows, it's called a command prompt. You can also access Python shell via the Python idle. The idle basically is what is known as an integrated development environment. It comes pre-built with Python. So when you install Python, it also installs the Python idle. And the Python idle has a Python shell. It also has its own text editor that you can use to write multiple lines of code. To access the command line interface on a Windows-based computer, you type in cmd inside the run command or search, and once you've got that open, you type in Python, and that will give you access to the Python shell. If you are on a Mac, you need to do a search for the terminal. Once you've got the terminal open, you need to type in Python 3, and that will give you access to the Python 3 shell. The reason you type in Python 3 on a Mac is that Mac comes pre-installed with Python 2, which is quite old. And once you've got Python 3 installed, to access it, you need to type in Python 3. If not, it gives you Python 2 if you just typed in Python. So I am on Windows, and this is my command prompt. So to access the Python shell, I just type in Python and press enter, and that should give me access to the shell. You can see this means that the shell is waiting for instructions. If you are on a Mac, you need to type in Python 3 on the terminal. So once you've got this flashing cursor, it means the shell is waiting for instructions. So I can do a simple maths. I can do 7 times 7 and press enter, and that will give me 49. So the shell, Python shell, is interactive. If you want to print out text on the console, you can use the print function. Python comes pre-built with a print function that allows you to enter the text you want to be displayed on the screen. So let's do a print function. You do a print, and then you have the parentheses. Inside the parentheses is where you specify what you want to print, and you need to enclose that in quotes. So I just say hello, and you close the quotes, and then you close the parentheses, and you press enter, and that will simply display the text hello. In Python, a text or group of text is known as a string, and the only way the computer can understand it if you put quotes around them. So you can't mix the quotes. You either surround the text with 2 single quotes or 2 double quotes, but you can't mix it with a single and a double. So it's worth noting that anytime you want to print a text, for the computer to know it's a text, you need to enclose it in quotes. To exit the Python shell, you just type in exit, and you enclose that in parentheses. So you got the opening parentheses and closing parentheses, and press enter, and that will exit the Python shell. Another way you can access the Python shell is via the Python idle, which comes pre-installed when you install Python. Now this is a shortcut I have to the idle, so I'm just going to click on it. You can also search for it in your search bar. That should bring that up as well. So I'm just going to click to open up the idle, and this is what the Python idle looks like, and you can see it opens up straight into the Python shell. So this is similar to the shell we had a look at earlier from the command line. All right, so those are a couple of ways you can access the Python shell. Hello and welcome to the part 2 of interacting with Python. In this part, we are going to be interacting with Python through a Python file. A Python file is basically a file that is saved with an extension ending in .py. So any text that is inside that saved file is interpreted as a Python code. You can create a Python file by using a text editor, or you can use the Python idle, which is an integrated development environment, which is also known as an IDE. I have opened up my Python idle. When you open up the idle, it opens up in Python shell. So Python idle consists of the Python shell and also the text editor. So to access the text editor, you click on File, and then you click on New File, and you basically just give the file a name. So I'm going to save this file with a .py file extension. So I'm just going to do file save as, and you give the file a name, and then you can see here it says Python file. I'll just call this app.py. Very important, you add the .py, and then you can save it in any location. For simplicity, I'm going to save mine on my desktop. So now that I've got a Python file, you can see here it's got app.py. I can just write one line of code just to test it. So I'll say print, and in parentheses I'm just going to add a quote. I'll just say hello world, and I'll close the quote, and I'll close the parentheses. I'll do a file, and I can just do save. So now this is my Python file, so I can run it from the Python idle, which is the IDE, by going on run, and I'll do run module. If I click on run module, it will run the file inside the shell. So I'll click on that. You can see here is giving me the output of the file, which is hello world, which is what I have, the line of code I have written inside the app.py. So this is one way of interacting with Python through a Python file. So this is the actual file here that I've saved on my desktop. This file you're looking at here, this is it here on my desktop. So to exit the editor, you just click on the X, and that will exit. And if you want to exit the shell as well, just click on the X and you can exit. Another way we can create a Python file is by using a text editor, and the text editor I'm going to illustrate with is called Atom. So I have got my Atom text editor open, so I'm going to just create a simple Python file. So I'm just going to save this file onto my desktop as a Python file with a .py extension. So this is the file I've created on my desktop. You can see it here. It's called my app. Okay, so let me go back to the editor. Because I've created it on my desktop, it also has a folder, so you can remove it. I'm just going to right click and say remove project folder, and it gives me more space. So let me just do a simple print statement. I'll do print, and I will enclose that in parentheses. I will just say, and I'll save that. I'll do file save. You can see now this is known as a Python file. So in order to, I can run this file from my terminal. So if I open up my terminal, I've got my command prompt here. So all I need to do, if I want to run this file, I'm just going to minimize the text editor. I can just drag, this is a file here. I just drag that into my command prompt. See, and it just tells me the location. If I press enter, it will execute. You can see it's executed the line of code I wrote. So that's how you can interact with Python from a Python file. So if you're creating a program or an application, you'll be writing multiple lines of code, sometimes hundreds or even thousands lines of code, and you can interact with Python that way. I'm going to briefly explain what Python expressions are. What are Python expressions? An expression is basically anything that has a value. It could be a number, it could be a text, which is also called a string, or it could be adding two numbers together using an operator. So an expression can contain an operator like 3 plus 4. The plus here is an addition operator. It can also contain upper hand. the upper hand is basically the actual values. Like 3 is an upper hand, 4 is also an upper hand. Statements are made up of one or more expressions. So let me illustrate some basic expression. I'm going to be using the command prompt on my Windows computer. If you're on a Mac, you can use the terminal. When you're on the terminal on the Mac, you need to type in Python 3. If you're on a Windows, just type in Python and press enter, and that gives you access to the Python interactive shell. So the first expression I want to write here is just to add two numbers together. So I'll say 3 plus 4, and I press enter, and I get 7 back. So the beauty of the interactive shell, it gives you a response to what it is you are typing in. Let's do another one. So I'll do 3 times 3 and press enter. That gives me 9. Let's do a text this time. A text is basically also known as a string. So I can just say hello world, and if I press enter, it gives me back hello world. Again, I can use a variable. A variable is something that stores data. So I can create a variable. I can say b equals to, you use the equals to assign a value. So I can say I want b to store the value of value of, let's say, 7 plus 7. And I press enter. Now if I call b will give me 14, because that's the value of adding 7 to 7. So these are just some basic examples of what an expression is. I'm going to introduce you to what a Python statement is. What is a Python statement? A statement in Python is an instruction to the computer to perform a specified action or task. In Python, a statement can be a single line, or it can be multiple line. Also, you need the Python interpreter to translate the statement you write for the computer to understand. The Python interpreter is automatically installed when you install Python. Let's take a look at how a single line statement can be written. Before you can write a statement, you need to invoke or activate the Python interpreter. So if you are on a Windows-based computer, you can open up your command prompt. If you are on a Mac, you need to open up your terminal. If you're on a Mac, you need to type in Python 3 once you have your terminal open. If you are on a Windows, just type in Python and then just press enter, and that will give you the Python shell. So once the Python shell is activated, automatically the Python interpreter becomes invoked or active. So to write a simple single line statement, basically I can just do a simple arithmetic. I'll do 7 times 7 and press enter. That is a single line statement because it's on a single line. So if I press enter, it gives me the answer. I can also use a print statement just to print out a single line of text. So I'll just, inside the opening parentheses, I will specify the text I want to print on the screen, which is hello. And then I'll close the parentheses, and if I press enter, it will just print out the text hello. So these are a couple of examples of a single line statement, because they are statements that are written on a single line of code. Let's take a look at how we can write a very basic multi-line statement. To write a multi-line statement from the Python shell, you need 2 characters, so you can use the slash character if you want to write multiple line, or you can use parentheses to write multi-line statements. Also, if you're using a text editor or an integrated development environment tool that has a text editor, you can write thousands and thousands or even million lines of code inside the text editor. But the illustration I'm going to show you is just going to be with the Python shell. So in my Python shell, if I want to write a multi-line statement, for example, I could say b is equals to, and then you use a slash and you press enter, and that allows you to add more lines. So I can just say 17 and I do a slash again and I press enter, and I can just add one more. I'll just say plus 16 and I press enter. Now if I refer to b, it will give me the total of the addition of all the numbers. So that's just a simple way you can implement multi-line. You can also use parentheses. For example, I can say c is equals to, and I'll have the opening parentheses and I'll press enter. This allows me to enter more line of code. Okay, so I just say plus, I'll press enter, and I can just add another number. Let's say 20. I'll press enter, and then I can just close the parentheses and press enter. Now if I type in C to give me 30, which is a total. So that's one example. Let's try and do an example that involves a string or a text. So let me say greetings. What I can get this to do is to store some information. So I'll say equals to, and I'll just say hello, and then I'll do a slash to give me another line, and in this line I'll add another text. I'll just say I wish you the best. That'll be another line. All right, and then I can just press enter, and that ends that. Now if I call greetings, it will just tell me what I have stored. So these are just some ways that you can implement multi-line and single line statement from the Python shell. Comments are very important in programming. They are used to tell you what something does in English, and they are also used to disable or deactivate parts of your program for testing purposes, or parts that you want to eventually remove from your program. And in Python, there are 2 ways you can implement comments in your program code. The first is known as a single line comment. If you want to comment out a single line at a time, you use the hash symbol. We also have the multi-line comments. If you want to implement or comment out multiple line of code, you use the 3 quotations there, and that will comment out the block of code you have specified the comment to take out. So let's take a look at how comments work. So I have got some lines of code inside my text editor. I'm using Atom, and this is the file here that I'm referring to inside my text editor. So these are just a bunch of print statements that will print these text onto the console. So I've also got my command prompt open here on the bottom, and my command prompt is basically where the code will be outputted, so to be displayed in the console here. So notice here I've changed directory to my desktop because the desktop is where this file is. This is the file I'm referring to. If you are on a Mac, you need to type in Python 3 followed by the name of your app before you can run it. The reason for that is that the Mac has both Python 2, which is pre-installed, and then the Python 3, which you would have installed. So you always have to specify which version of Python you're referring to on the Mac. So let me print out this program here, what's inside this file, just by calling the file name, which is this. So I just say my app.py because it's a Python file, and I'll press enter. And you can see here it has displayed the output from here, displaying what's in here. That's the first line, and this is the last line here. So let's say I don't want the first line to be displayed. I want to take out the first two lines. And the way I will do that is just add a comment, just use that. You can see it comments out that line completely. And if I want to take out the second line as well, I just put a hash. And that you can see the coloration has also changed, and that takes out those two lines. So let me just save that. And if I run the program again, just by moving the up arrow on my keyboard, that will run it again. I just press enter. Now you can see it starts from here on line 3. That's the text there. It's not displayed line 1 and 2. You can see no line 1 and 2 here. It starts from line 3, which is this one, and ends on line 6, which is that one. So that's how you implement a single line comment if you want to comment out a single line of code. Also, when you comment out a line of code, you can also write some text just to if you want to be more descriptive of what it does. Now you can also have comments that will not impact on the code running. Say for example line 3 here. Let me minimize this screen. In fact, let me clear this to create some space. So I'll clear that and I'll minimize that. So let's say on line 3 here I want to add a comment. So I can add a comment. If you add a comment on the right hand side, it does not impact on the code. It will not affect it. You can see it hasn't changed the appearance or the background color. All right, so when the idea of putting a comment on the right hand side is that you can then add some text to say what this line does. So I can say this line prints this blah blah blah. So it's just, I can then add a descriptive text as to what that line of code does. So that's how you work with single line comments. So I'm just going to take that out, the single line comment, and take this one out as well. Now we have the multiple line comment. So let's say I wanted to comment out multiple lines. So let's say I come here. So you just do 1, 2, 3, has to be 3. And then I come here on the bottom and I do 1, 2, 3. So you can see everything here has turned green. You can see the print here is no longer highlighted as blue because everything here is now commented out. So this is, I'm commenting out multiple lines of code at the same time. So let me save this and then try and run it again in my console. So again, I just type in the name of the app, my app.py, and it should only run the first two lines of code. And that's because the other lines have been commented out. Okay, so this three this three here quotes and the three here. That's how you do a multiple line comment. And you can also add text to that to describe what you are commenting out. So comments are very useful. If you don't want the code to be affected, you can obviously use single line comments to comment out on the right hand side what that line of code does, or you can add multiple line comments and then just write some descriptive text of what that block of code is doing or is meant to do. So comments are very useful because there may come a time you may want to test certain aspects of your code. You don't want that block of code to run, and the way you do that is to just comment out either that line of code or the entire block of code, and that will prevent that section from executing when the code runs. Indentation in Python is used to separate or section off parts of a block of code. Python, unlike other languages, does not use semicolons or curly braces to indent code. Python uses white spaces to separate code blocks so as to indent the parts of the code. So indentation in Python is very important. Indentation in Python can be created using tabs or spaces. However, it is recommended that you use spaces and not tab to indent. And when you do use spaces for indentation, make sure that there are 4 spaces. It could be more, but it is recommended to indent using 4 spaces. It's also advisable not to mix the indentation. So don't indent with spaces and also indent with tabs. That would confuse Python. So I would recommend you stick to using spaces to indent your code. Inside my text editor, I've got a Python file, which is this file here on my desktop, and this is the content of the file. So you can see here the print statements are all on the same line, which is okay. So if I run this block of code inside my terminal on the bottom here, so I just need to call the application by its name. So I do my app.py. If you are on a Mac, you need to type in Python 3 followed by the name of the Python file before you can run it. Now you can see here the content of the file has been outputted in my console here. Now these lines of code as it is properly indented. So indentation, if I wanted to, for example, now if I should indent that, just do that. This, and I try to run this file again, it will fail because the indentation is out of line, is not appropriate. So let me go to my terminal and run again. I expect to get an error. You can see here it tells me, gives me that, say print, tells me where the error is, which is this on line 2. You can see that it says silence is true friend, which is this one. So it's telling me that the indentation is not correct. So once the indentation is wrong, it does not run the code. This is very important when you are writing several lines of code to make sure that it is properly indented. Okay, because these are all single line statements. They have to be on the same line. So that's why the indentation is important. If you had several blocks of code in different sections, you use indentation to separate the sections of the code so that each block belongs to a certain section. With single line comments like this, it's okay because these are just print statement and they all should be on the same lines because they are not part of a block. They are independent. So they have to be on the same line. If you try to shift them like I did in this one, it impacts, because it means the indentation is not correct and therefore gives you an error in the application. So that's basically how indentation works. So it's very important in Python. I'll be talking to you about a very important concept in computer programming called variables. Variables are very important. They allow you to store various pieces of information that you can use for your application. If you look at big, large applications like Facebook, Instagram, Twitter, and a host of others, they all use variables to store and retrieve information. Even your bank, when you go to get some money from the bank or from the machine, it all stores information and retrieves information. All that is done using variables. So what is a variable? Variables basically is a holding container that is used to store a value that can be referenced as of when required. The value that the variable stores can vary. That means they can change, hence the name variable. Variables are parts of your computer's memory where information can be stored. The variables are given names in order to identify them. We then use the names to retrieve the information that the variable stores. Variables can hold values of different types. That means they can store number related values. They can also store string or text related values. Before creating variables, it's good to know some common convention when you are naming your variables. Variable names are case sensitive, so you got to be careful when you give your variable names. For example, if you name a variable age and then try to reference it using capital letter A, it will not respond because they are treated as two different things. So make sure when you're creating variables, you reference them using the exact name and case that you have created them in. Names in variables can be letters, they can be alphanumeric, so they can be letters and contain numbers. They can also contain signs like a $sign or the underscore. Variable names cannot start with a number. You can embed a number in your variable name, but you cannot start it with a number. For example, you can't call your variable 247 learning. You can start a variable with lowercase word. If you have a variable that has two words, you can start it with the first letter being lowercase, and then you can add the additional letters with an underscore. Doing it this way makes it a snake case. So when you have two words separated by an underscore for a variable name, is called a snake case. You can also represent it in camel case. Camel case basically means the first word is lowercase and the second word becomes uppercase. They call it camel case because it looks like the hump of a camel. Also, when you name your variables, try to give your variable descriptive names that indicates what type of data or things that the variables actually stores. For example, if you are creating a variable regarding the score that a game stores, you can call it game underscore score. That is a good descriptive name for the type of information that variable stores. Also, when you are creating variables, it's very important to know that you cannot use the Python reserve keywords. Reserve keywords, these are words that the actual Python programming language uses for different things, so you cannot use them. So this is a table showing you the key words in the Python programming language. These are words that you cannot use as variable names. We are going to be creating some variables. Creating variables in Python is really straightforward. All you need to do is give the variable a name, and then you assign some values for the variable to store. I'm going to be using my command prompt to create some variables. So I'll be accessing the Python interactive shell. So to do that, I just type in Python and press enter. If you are on a Mac, you need to go to your terminal and type in Python 3. So the first thing you need to do when creating a variable is to give the variable a name. So give it a name that is descriptive, that reflects what type of data or value that the variable stores. So let's say I create a variable age, and you use the equals to assign a value. So I'll say I give it an age of 4. I press enter, and that's the variable created. If I want to access that variable, the value inside that variable, all I need to do is call the variable by its name and press enter, and it will return the value. You can also change the value that the variable holds. For example, I can come here and say age equals to 5 and press enter. Now, if I call that variable age, it will no longer store 4, it will now store 5 because the value has changed. So the value that a variable stores can vary. So let's say I create another variable and I give it a value of, say, blue lime. Now, if I want to reference name, I'll just say name, and it will give me the text blue lime. If you notice, there are quotes around it. If you don't want the quotes, you can just do print. I can just say print name. By wrapping the variable inside the print function, it will print out the value without the quote. So let's create a few more. So I'll create another one called city, and I give it the value of, say, London. I will create another variable. So I'll create one called greeting, and inside this I can store a long piece of string or text. So you can always store what you like inside your variable value. So I'll say hello world and do that. So I'll say hello world, and I'll say thank you. So variables are quite useful. So for example, anytime I want to say something like this, I don't need to keep typing it out each time. I just call the variable by its name. For example, I can say print, and inside the print function, I just pass in the name of my variable, which is greeting, and it will just spit out the value. You can see here, it's just printed out the value of that variable. So variables are quite useful because you can store a lot inside them, and that saves you typing things all over and over again. So if you have values that you want to use or reference often within your application, you can store those values inside variables and then just change it as you go along. You can also construct a sentence or statement using variables. For example, I could say print. Inside my print function, I could construct a simple sentence. So I could say name, which is a name of, I've got a variable called name with the value blue lime. So I could say name, I do a comma, and then the quote, I'll say is from, and I'll end that quote, and a comma, and I'll say city. Now, the name and the city are both variables. So I've got a name here with the value blue lime. I've got a variable here called city with the value of London. So what I'm saying here is I want this print function to print out the name, which is blue line, and then add this piece of text, and then add this variable name. So if I press enter, you can see it's constructed something saying blue lime is from London. So you can see the power of variables. You can store any data type, you can store numeric related values, and you can store string or text related values. Also, variable names can change, so you can create variable values can change. You can create a variable and then later on reassign the values that the variable holds. So that's it for creating variables. When you are programming, there will come a time when you want your program to be more interactive and capture some information from users. In Python, you can achieve this by using a special function called the input function. This function prompts the user for some information. What you can then do is capture that information that the user enters and store that information into a variable, and then you can interact with the information the way you want. I'm going to create a new Python file to show you some examples of how to capture information from users. So I'm just going to right click on my main project directory. I'll right click and go new, and I'll click on Python file. I'm just going to call this input and click OK. So it's now created a new file called input.py. So to capture information from a user, you need to use the input function. And what you can do, you can store the information that you do capture into a variable. So let's say I create a variable called person, and I'm going to set it to equals to an input function. Now inside that input function, I'm just going to add some text that will prompt the user what to do. I'll just say enter your name. So depending on what type of information you're trying to get from the user, you can have as many input functions as required. For example, you can have an input function that will prompt users for their age and other kinds of information, and then store that information into a variable. So once we have captured that information, we might want to output that on the screen, and we can do that using the print function. So inside the print function, we can just add a text. So what this will do, basically, once the user gets the prompt, they enter the name, and then this will print hello plus whatever name they have entered. So I'm just going to save my file, and then I'll play this file. So I'll click on play, and you can see here is now giving me the prompt to enter some information. So I'm going to enter some information. I'm just going to say blue lime, and when I press enter, it's going to say hello blue lime, because blue lime is the value I have supplied for this variable called person. So I press enter, and you can see here it says hello blue lime. So this is just a simple way to capture a user's input. So you can have different types of input depending on the type of data or information you want to get from the user. You can also capture numeric input from a user. So let's create some variables. So if I create a variable x, and I'll give it, say, a value which will be equals to an input function. So I'll say input because I want to capture the information from the user. So inside that input function, I'm just going to enter a text that says enter, and then I'll create another variable. I'll make this one y, and I'll set it again to an input because I want to capture some information from the user. Again, I'll say enter, okay, and then I can have another variable called z, and I'll set this to equals to x plus y. Okay, and then I can do a print statement and print z. So when I play this file, I want you to watch the outcome carefully. It's not going to be the result you expect. So you would expect an addition to take place, but what's going to happen is you're going to get a concatenation. Concatenation is when you add two strings together. So let me click on the play button. You can see it says enter your name. It's referring to this first print statement on line 2. So I'll just say and press enter. All right, so it says hello blue line. Now it's gone on to this print statement here on line number 8. All right, so it's basically responding to this. So it says enter a number. So I enter number 8. I press enter. It's asking me to enter another number. Don't forget I've got 2 input functions. So I enter number 7. Now if I press enter, you would expect the result to be 15, but it's not. It's going to say 87. You see, it says 87. And the reason it has said 87 is because it has added the values I've provided together. It's treated them as a string. So it thinks they are text and just added them together. When you add strings together, it's known as concatenation. So what we need to do here, we need to do some casting so that this value that it captures is converted into a number or an integer. In order to convert the values that has been captured from the user into a number value, an integer, I need to do some casting. So what I'm going to do here in this variable z, this is where I'm going to do the casting. So what I'm going to do, I'm going to wrap this around a print statement. So I'm going to say print, and I'm going to wrap that result, but I need to include a special function called the int. This is what will convert the value that I capture from x, and I'll do the same here. I will add this function called int. It will convert whatever value that is being captured from y as well. All right, so that will then give us a proper addition. So I'm going to modify the code. I'm going to comment out line number 8. We would not need that anymore since we have wrapped the value of the variable z inside this print function. I'm also going to comment out line 1 and line 2. I don't really want those line of code to run. So I just want to keep things simple so we can focus on this area. So what we'll now get, we'll get a prompt to enter a number. We enter a number, we enter a second number, and then in this variable z here, it will print the number that was entered for x, but then convert it, because when it's entered at the input level, it's a string. So this int here is going to do some casting by converting the captured number into a whole number. It converts it from string to number. It does the same with the y. So let me just save my code and then play the code again. So I click on play. Now you can see here it's asking me to enter a number. So I say 8. I enter a number 8, for example. I press enter. It says enter another number. Say I press 4. If I press enter now, it should give me the correct result, which is 12. Okay, and the reason it's giving me the correct result is because I have done some casting here. Using the int function, it converts the value that was entered for the x variable into a whole number. He also converts the value that was entered for the y variable into a whole number, because any value entered using just the input function is treated as a string or a text. All right, so we have to cast by changing the data type of what was entered. That's why we were able to get the correct result of 12. So that's basically how you can capture input or information from a user. It's very useful. So depending on what type of information you want your program to capture, you can use that to do different things in your program in order to create some kind of interaction with the user. So that's basically how to capture user information by using the input function. What are algorithms? Algorithms basically are a list of rules or a set of instructions that you want the computer to follow in order to achieve a task or solve a problem. And the list of rules or set of instructions must be followed in a specific order. It's important that the sequence of order is followed in order to achieve the desired result or get the problem solved. So algorithm is basically a set of instructions that a computer has to follow in order to solve a problem or achieve a task. Let me walk you through a very simple algorithm that you would use, for example, to make a cup of tea. So you start off by putting a tea bag in a cup. You fill the kettle with water. You then boil the water in the kettle. You then pour some of the boiled water into a cup. You can add milk to the cup. You can add sugar to the cup. You can also stir the tea in the cup. And finally, you can drink the tea. So these are the steps that you would take normally to make a basic cup of tea. Obviously, the steps might change differently depending on who's making the tea, but just to give you an idea of how algorithm works. Now, computer works the same way. When you give them instructions to do, they will follow the instructions in the order you have written the instructions. So it's important to get the sequence of order right to achieve the desired result. Now, what we have here displayed is known as a pseudocode. Pseudocode basically is not the actual code, it's a representation of how your visualization of how you want the code to be. So let's now go ahead and print a triangle in the console using the print statement. The print statement we have used before in the course. It's very important. It's basically used to print a bunch of text or stuff on the screen or in the console. So a programmer basically gives the computer a set of instructions to carry out. So let's go ahead and give the computer some instructions to print a triangle on the screen. This is a Python file that I had in a previous video. So I'm just going to comment out these lines of code because I don't want them to run when the code is executed. So now let's go ahead and get the computer to print a triangle on the screen. So you start with a print statement, and the print statement is basically used to print stuff on the screen. So I'm just going to copy this 3 more times just to save time. And that's 1, and this is 2, and I do one more, and that is 3. That's 4. All right, so now I've got a bunch of print statements. So I'm going to make some adjustment here. On the first one, I'm going to create 4 spaces, 1, 2, 3, 4, and then I'm going to add a slash and a forward slash like that, a pipe symbol. That's for the first one. For the second print statement, I'm going to tap 3 spaces, 1, 2, 3, and then do a slash like that, and then I will add the pipe symbol. So make sure they are on the same line. On the other print statement, I'm going to tap 2 spaces, 1, 2, do a slash and do a space and do the pipe. So make sure they are all on the same size. On the fourth one, I'm just going to tab 1 space and do a slash, and on this one I am going to do something extra. I'm going to add an underscore, so do 1 underscore, 2 underscore, maybe another underscore, and then I'll add the pipe symbol. So you can see already it's looking like the shape of a triangle. So if you notice what when I execute the code in this Python file, the computer will do things in the order I have specified. It will first of all print this here with space. It then goes on and say, okay, now I've done this, they want me to do this. It'll go on and do that one, and so on. So let me save this file here. I'll do save, and I'll open my command prompt terminal. This is a file here that I'm trying to run, the Python file. I just type the name of the file. If you're on a Mac, you need to type in Python 3 before you type the name of the file. So I'm just going to type the name, which is myapp.py, and if I press enter, I expect it to print out the triangle. You can see here it's printed out the shape of the triangle on the screen here. So it's been able to do this because of the algorithm, because of the sequence. All right, if I amended any of the sequence, it will no longer be a triangle. So the order in which you give the computer instructions is very important to achieve the desired result. I'm going to give you a quick introduction to what operators are in Python. I will also show you a list of some common operators that are used in Python. So what are operators? Operators in Python are used to provide functionality that does something with some values. So you have a value, it could be a numeric value or a text related value. You can use operators to manipulate that values. Operators are basically represented with symbols such as a plus symbol. There are different types of operators. The plus basically is used to do addition. Also, operators require some data to operate on or work with. The data that the operator uses is referred to as the upper hand. For example, we have 3 plus 4. 3 and 4 are known as upper hands, while the plus or addition symbol is an operator. Let's take a look at some common operators that you can use in Python. The first is the arithmetic operator, and that's basically used to perform different types of mathematical operations on a set of values. And then we have the assignment operators, basically used to assign values. We have comparison operators used to compare values. We have logical operators. Logical operators are basically used to combine conditional statements. We also have the identity operators. The identity operators are basically used to check that if certain values are the same. So they will compare the values of certain objects and check if they are the same or not. Next, we have the membership operators. Membership operators are basically used to check or test if a certain value exists in a sequence of values. And finally, we've got the bitwise operators. The bitwise operators are the type of operators that are used to compare binary numbers. Binary numbers are numbers that are represented in zeros and ones. So these are the basic operators that you can use in Python. I'll be talking to you about Python arithmetic operators. Arithmetic operators are operators that are used to perform some type of mathematical operation. So here is a list of some commonly used operators in Python. Some of these operators you may already be exposed to. So I'm just going to run through them. The addition operator is basically used to add values together. We've got the subtraction operator that is used to subtract or take away one value from another. We have the multiplication operator that is used to multiply values together. We have the division operator, which is used to divide one number by another number. And then we have the modulus operator, which is represented by the percent symbol. The modulus operator basically divides two numbers but only returns the remainder after the division. Next, we've got the floor division. The floor division basically performs a division on some values but will only return the nearest integer to that value. An integer is basically a whole number. I've got my Python interactive shell open, and I'm going to use that to illustrate how some of the arithmetic operators work. And the first operator I'm going to experiment with is the addition operator, which basically adds two numbers together. So I'm just going to add a number 3, and I'll use the addition operator to add another number. So I'm adding number 3 to 4. I press enter and that should return 7. I can also do a subtraction or a takeaway. So I can say the value 47, take away 14, and press enter, and that gives me a value. You can also have a negative value return. For example, if I say 3 minus 5, that should give me a negative value. So it's giving me a negative 2 because 3 is a lower number than 5. You can also do multiplication. So I could multiply two numbers. I could say 3 multiply by 3, and that will return 9. You can also do multiplication on a string or a text. For example, I could have a string called la, and I could do a multiplication on that. I could do times 3. What that will do, it will return la, 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 la 3 times. So you can see it's giving me la, la, la. You can also do a division. Division is basically divide one number by another. So I could say 12, and the division symbol is just a slash. I'll say 12 divided by 4, and that will return 3. You can also do what you call exponentiation, when you raise one value to an exponential level. So if I have the value of 3, I can do double 4. What that basically means, I want it to raise the value of 3 to the power of 4. So that means 3 times 3 times 3 times 3. That's what that means. If I press enter, it gives me the value of 81. That's known as an exponentiation or exponential value. It's sometimes called POW or power, when you raise something to the power of another number. Another operator I want to illustrate here is called the divide and floor. What that does, it returns the nearest integer after a division. So I could say 13, and I would do // which represent I'm doing a divide and floor, say by 3, and press enter, and that only returns the nearest integer, that is the nearest whole number. The final operator I want to illustrate here is called the modulo operator. What this modulo operator does, it will perform a division, but it only returns the remainder after the division. So if I do 13 and do a percent is what you use to represent a modulus operation. So I do 13 and I do a modulus on 3. So what that would do, it will perform the division but only return the remainder after the division. So you can see when you divide 3 by 13, it gives you a remainder of 1. So these are some common and basic arithmetic operators that you can use in Python. I'm going to talk to you about the Python assignment operators. What are assignment operators? Assignment operators are the type of operators that are used to assign values. This is a small table just showing some assignment operators in Python. There are a lot more. I've only just listed a few, but the principle is the same. So the equals to basically is what you use to assign a value. Then you've got the plus and equals to, which is also the same as saying a value plus another value. Then negative equals to is the same as taking away or subtracting one value from another value. You've also got the multiplication, the division, and so on, but the format is exactly the same. To illustrate how the assignment operators work, I'm just going to create a very simple variable inside my Python interactive shell. So I'm going to create a variable. I'm going to call it D just for simplicity, and I'm going to assign it a value of 8. Now, if I wanted to access that variable, all I need to do is call the variable by its name. I can just say D and press enter, and that will return the value that that variable stores. I can also use the plus and equals to add a value to a variable. So I've got this variable D, and I can add the plus and equals to assignment operator, and then I will add a value. So if I say 4, basically what I'm doing here, I am adding a value to the variable I have created. So I expect it to return 12. Now, if I call this variable D, because I've added 4 to it, it should now return 12. You can see here it's giving me 12 because I've used the plus equals to add to this original value. You can also use the negative equals to assignment operators. Basically, you use that to subtract a value. So I can come here and say my variable that is D, and I can add the negative and equals to operator and then add a value. What I'm basically saying here, I want to subtract 5 from the value of my variable. So notice my variable now has a value of 12 because I added 4. Now I'm using this operator, assignment operator, negative equals to remove 5 from that value. So now if I call that variable D again, it should have subtracted 5 from it. You can see when you subtract 5 from 12, it gives you 7. In these few examples, I have used the equals to assignment operator. I've used the plus equals to assignment operator. I've also used the minus equals to assignment operators. There are other types of assignment operators you can use. You can also use the multiplication equals to. You can use the division equals to. So they will work in the same way that the operators I have illustrated work. What are comparison operators? Comparison operators are operators that are used to compare values. So let's take a look at some of the comparison operators that Python has. So we've got the operator, which has the double equals to sign, that is used to check if one value is equal to another value. Then we've got the exclamation mark and the equals to, that checks if one value is not equal to another value. We've got the greater than operator, which checks if one value is greater than another value. We've got the less than operator, which checks if one value is less than another. We've got the greater than or equals to, which checks if a value is greater than or equal to another value. We've got the less than or equals to, which checks if a value is less than or equal to another. Notice that with the double equals, that is used to check if a value is strictly equals to another. If you're using a single equals to, you are assigning a value. So know the difference between using double equals and just a single equals to. When you're creating variables, for example, you use just a single equals to assign values to the variable. I have got my Python interactive shell open, and I'm going to create two very simple variables that I'll be using to illustrate how the comparison operators work. So I'm going to create a variable. I'm going to call it B, and I'm going to give it a value of 4. Notice that I've used just a single equals to. When you use a single equals to, you use that to assign a value. So I'm going to press enter and create another variable. I'm going to call this C, and I'm going to give it a value of 3. I'll press enter. So those two variables have been created. Now I want to compare these two variables using the double equals to, which is the equals to comparison operator. So I'm going to wrap it around a print statement or print function. So I'll do print, and I'm going to compare the values. So I'm going to say B. So this is checking if B is equals to, notice I've used double equals to compare the value. So I'm saying, is the value of the variable B strictly equals to the value of the variable C? That should return false because 4 is not equals to 3. So I can also use another operator which is called not. So the not comparison operator, I'm going to use that to check if a value is equals to another value. So I'm going to check if the variable B, I'll say B, I'll say equals to. So when you do the exclamation and equals to, you are checking, you're saying that one value, you're checking if one value is not equals to another value. So I'm checking here, I'm saying B is not equals to C. That will return true because 4 is not equals to 3. Next, I want to use the greater than operator to check if the value of one variable is greater than the value of another variable. So I'm going to say, I'm going to check if B, the value of B is greater than the value of variable C. 4 is greater than 3, so I expect it to return true. You can see it has returned true. I can do the opposite, which is check if a value is less than another. So I'll do a print and I will check if B is less than C. So B is 4 and C is 3. B is definitely not less than C, so I expect it to return a false because the values are not the same. You can also check if a value is greater than or equals to another value. So I'll do print, and inside my print function, I can check if the variable B is greater than or equals to the value of variable C. Now that should return true because 4 is greater than or equals to 3. All right, so I can do the reverse and check if a value is less than or equals to another value. So I'll do a print, and inside that print function, I would say I'm checking if the variable B, the value of the variable B, is less than or equals to the value of variable C. I expect this to return false because 4, which is the value of variable B, is neither less than or equals to 3. So these are some basic comparison operators in Python. What are logical operators? Logical operators are the type of operators that are used to combine conditional statements. What that means is that they check certain conditions are true and then evaluate to true or false. So let's take a look at the common logical operators. So we've got the AND logical operator. What that does, it will check and compare if all conditions are correct. If all conditions are correct before it executes the code, it will evaluate to true. The OR operator will execute if either condition is true. All condition does not have to be true when you're using the OR operator. As long as one of the conditions is true or has been satisfied, it will return or evaluate to true. When you're using the AND operator, all conditions must be met or they must evaluate to true before the code will execute. If not, it returns false. The NOT operator basically will return false. So what that does, it just reverses the result of the output. So if it was previously true, it will just reverse it to false. I'm going to illustrate how the logical operators work using the Python interactive shell. I'll be using the interactive shell on my Windows computer via the command prompt. If you're on a Mac, you can do this using the terminal. Once you've got your terminal open, just type in Python 3. If you're on the Windows, just type in Python and press enter. That will give you access to the interactive shell. So I'm going to start by creating a very simple variable. I'm going to call it A, and I'm going to assign a value of 7 to that variable. So I press enter. Now I can use the AND operator to compare setting conditions, and if the conditions are true, it will return true. So I'll say print, and inside that print function, I will say the variable a is greater than 6, and then I'll use the AND operator, and the variable a is less than 9. So if you notice here, I'm using the AND operator here to compare two conditions. The first condition, I'm checking if the variable a, which has a value of 7, is greater than 6. And then I'm using the AND operator to check if the variable a is less than 9. So there are two conditions here. So this is going, if the condition is true, it will evaluate to true. So if I press enter, you can say it's true. And because the condition on the left is true, a, which is 7, is greater than 6. Condition on the right is also true. A, which has a value of 7, is less than 9. Let me show you how the OR operator works. So I can do the same example. I could say print, and inside that print function, I could say a is greater than 6, and then I use the OR operator. I'll say OR a is less than, say, 5. Now the statement on the right hand side here, this expression here, we know is false because a is 7, and here I'm saying that a, which is 7, is less than 5. This is not true. However, the statement on the left is true. A, which is 7, is greater than 6. So this here we evaluate to true. That's because one of the condition has been met. The condition on the left is true, while the condition on the left is not true, but it will evaluate to true. When you're using the AND operator, both conditions you're comparing must evaluate to true before you get a true back. So, but the OR, you only need to have one side of the comparison to be true to return a true value back. So the final operator I want to show you is the NOT logical operator. So I'm going to say print, and inside my print function, I'm going to use the operator. I'm going to say NOT, and inside that I will add the condition. I'll say a is greater than 6. That's the variable a is greater than 6. All right, and the variable a is less than 9. Now this is true. This is true, but because I've used the NOT operator here, this NOT logical operator will return false, because the main purpose of that operator is to reverse the result. All right, so this statement here, this value is true. A is greater than 6 and a is less than 9. You can see I defined a with a value of 7, but by using this NOT operator, it reverses the result of the output. The identity operators are type of operators that are used to check and compare if objects are of the same type. So seeing in this table here, we've got two main types of identity operators. The first is called the is. What that does, it returns a true value if the objects it's comparing is the same. And then we've got the is not identity operator that will check a set of values and it will return true if the objects it is comparing are not of the same type. To show you how the identity operators work, I have created 3 sets of variables in my Python shell. The first variable I have called fruits, and it has 2 elements, grapes and berries. I've got another variable called my_fruits. Again, it's got 2 elements, grapes and berries. Notice the values are the same of type and also position. I've got another variable here called fave_fruits, and I've set it to equals to fruits, which is this variable here. So I've said I want the value of this to be the same as the value of fruits. Now we're going to use the identity operator to check and compare some objects or values. So I'm going to use the is identity operator to check if the objects are the same for the variables I am comparing. So I'll say print. I'm going to use a print statement. So inside that print statement, I would say fruits, which is the name of my first variable, and then I'll use the identity operator. I'll say fruits is, and I will say fave_fruits, which is my other variable name. All right. Now, what this is identity operator is doing is checking if the objects are exactly the same. As you can see, they are the same because I've said this variable should be equals to this fruits, which is the name of this variable. So the objects are the same in comparison because they have exactly this. Here is just a replica of this. So I expect it to return a value of true after comparing them. So I press enter to that, and you can see it has correctly returned true because I've set this variable to equals to this variable, which means they will have everything exactly the same. I'm going to use a print function, and inside that print function, I'm going to pass in the name of my first variable, which is called fruits, and then I will add the identity operator is to check, and I'm going to check my second variable, which is called my fruits, my_fruits. So I'm doing some comparison here to check if you notice that this variable called fruits has 2 elements, grapes and berries. This variable called my fruits also has 2 elements, grapes and berries, but they are not the same object. So using this identity is operator to check should return false. So if I press enter, you can see it's returned false. And the reason for that is that they are not the same object. Even though they have the same type of content, the object is not the same. So let me show you how the not in identity operator works. So I have got this variable here, and it has grapes and berries. Say if I want to check if a certain element is not included, I can use the not in operator. So I'm going to wrap that inside a print function. So I'll say print, and I will say apples. I know apples is not in my list, so I'll say apples, and then I'll use the not in identity operator. I'll say not in, and the variable I'm checking for is called fruits, and that should return true. And the reason for that is because apples does not appear in the sequence of values. So that's basically how you use the identity operators. What are membership operators? Membership operators are the type of operators that are used to test or check if a certain value is available within a group of value or sequence. So it checks to see if a value is there or not. If it is there, it returns true. If it is not, it returns false. So there are two main types. We've got the in operator. This operator will check in a sequence of value if certain value that you've specified is present. If that value is present, it will return a true value. The not in checks to see if a specified value is within a group of value. If that value is not present, it returns true, which means that value has not been found. So let's see how the membership operators work. I'm going to open up my Python interactive shell using the command prompt on a Windows-based computer. So if you're on a Windows-based computer, just type in Python and that will give you access to the interactive shell. If you're using a terminal on a Mac, you need to type in Python 3. All right, so I'm going to create a variable. So if I create a variable, I'm going to call it fruits, and I'm going to give it a value. So inside that value, I'm going to give it grapes. That will be one value. I'll do a comma and I'll add another value. This one I'll call berries. Now, if I want to check if a certain value is present in this variable or list, I can use the in operator. So I'm going to wrap it around the print function. So I'll do print and I will say print, and the value I'm checking for is berries. I'll say I want it to check if berries, and then I'll use the in operator. I'll say check if berry is in the variable called fruits, and if it is, it will return true. You can see it has returned a value of true. If I specified a value that was not in that variable fruits, it will return false. I can also check if a specified value is not in a group of values. So I can use the not in operator. So I can check, I'll wrap it inside my print functions. I want to check if apples is in my variable called fruits. So I can say apples not in. So I'm using the not in operator, not in fruits. And if I press enter, that should come as true because apple is not in the listed fruits inside my variable called fruits. So that's basically how the membership operator works in Python. I'm going to introduce you to binary numbers. What is binary? Binary basically is a way that the computer interacts. So any instructions you give the computer, it does that in a binary format. So it's basically a language for the computer to perform its task. It consists of zeros and ones. It is a system of counting. It's also known as the base 2 system. That's the way the computer understands it. So let me show you a quick way to convert numbers to binary format. What you need to do when you're converting numbers to binary, you have to keep dividing that number in half until you get to 1, and you ignore the remainders as you go along. So let's say I want to convert this number 13 to a binary format. What I'll need to do is keep dividing that number in half until it gets to 1 and ignore all the remainders along the way. So let's start with the number 13. So if we divide that in half, that will give us 6. We ignore the remainder. Now if we divide 6 in half, that will give us 3. If we divide 3 in half, that would give us 1. So now that we've divided the number in halves, we need to apply the binary format to it. So the way the binary format works, it assigns a 1 to odd numbers and a 0 to even numbers. So the 1 here will become a 1, the 3 will be a 1, the 6 will be a 0, the 13 will be a 1. So the binary number for 13 is 1101. Next, let me show you how to convert a binary number into a normal number. So let's say we have this binary number and I want to convert it into a number. The first thing we need to do is that we need to find the exponential value, and it goes from right to left. So what we need to do, we need to keep raising the value from power 0. So the first will be, we'll raise that to 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and so on. So depending on how many bits you have. So individual, each of these are regarded as bits. So depending on how many bits you have, it depends on how long the exponential value goes. So now that we have got the exponential values, what we need to do is add them together. And in adding them together, we'll ignore anywhere that is got the zeros, because if you multiply any number by 0, it will give you a 0. That's why we're ignoring the zeros and we're focusing on just the 1. So we'll start with the first one, and 2 to the power of 4 means you do 2 times 2 times 2 times 2, and then we add the addition. We add that to the other one, which is 2 to the power of 1, basically 2 times 1. And that will give us 16 plus 2, because 2 to the power of 1 basically means 2 times 1, which is 2. And 2 to the power of 4 is 16. And that will give us 18. So the binary conversion of 10010 to number is 18. You can also convert a binary decimal to a number decimal. So let's say I've got this binary decimal, which is 1100.101. So how would I convert this to a number decimal? I've already worked it out. I'll just show you and explain. So this is how it works. So this again, we do like the previous example I showed you. We do to the power. So 1 here will start from this area here. So this first 0, which is this one, will be raised to 2 to the power of 0. This one will be raised 2 to the power of 1. This 2 to the power of 2, 2 to the power of 3. So we'll work on this block first before the decimal. And what this will do, it gives us, this is 2 to the power of 3. We ignore the zeros because any power multiplied by 0 will give you 0. So we ignore anywhere that's got the 0 in bytes. So this is 2 to the power of 3 for this one here, plus 2 to the power of 2 for that. We ignore the zeros. And then after the decimal, the power becomes raised to negative. Notice here, this is the raised to negative 0 to power of 0. And then once we move on to after the decimal, it becomes negative. This is 2 to the negative 1, 2 to negative 2, 2 to negative 3. Again, we ignore the zeros. So we are adding these 2 to the power of 3 plus 2 to the power of 2 plus 2 to negative 1, 2 to the power of negative 1 plus 2 to the power of negative 3. We ignore the zero. So now we now add them all up. Okay, so 2 to the power of 3 is basically 2 times 2 times 2. That will give you 8, plus 2 to the power of 2, which is 2 times 2, that's 4, plus 2 to the power of negative 1, which is basically half, and then plus 2 to the power of negative 3, which is plus 1 over 8. 2 to the power of negative 3 is 1 over 8. So now if we add them all up, it gives you 12, plus half is 0.5, and then 1 over 8 is 0.125, and that gives you that value in decimal. So the decimal equivalent of this binary number, that's a decimal, is 12.625. If you can remember this chart here, it will make your working with binary numbers quite straightforward. So anything that is raised to the power of 0 is 1. Anything raised to the power 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16, and so on. 2 to the power of 5 gives you 32. 2 to the power of 6, 64, and so on. So once you can memorize this, it will make it much easier for you to work with binary numbers. Also here, we've got the equivalent. So anywhere you have a negative to the power, then it's 1 over the relevant value. So you can see here, 2 to the power of 4 equals 16. If we have the negative equivalent, it becomes 1 over 16. The same thing here, 2 to the power of 5 is 32. The negative equivalent is 1 over 32. 2 to the power of 6 is 64. The negative equivalent is 2 to the power of 6, which is 1 over 64. So if you can have an idea or memorize this, it will make, again, working with binary numbers much easier for you. I'm going to introduce you to some bitwise operators. Bitwise operators are operators that are used to compare and work with binary numbers. The first bitwise operator I want to talk to you about is called the AND operator, and it is used to set each bit to its corresponding matching value. If the value does not match, it sets it to 0. Let me explain how the AND operator works. Say we have two values. We've got value X, we've got a value Y, and then we've got the output, which is the result of X and Y. If X has a value of 0 and Y has a value of 0, the corresponding output will give us 0. If X has a value of 0 and Y has a value of 1, the corresponding output will give us a value of 0. If X has a value of 1 and Y has a value of 0, the corresponding output will be 0. If X has a value of 1, Y has a value of 1, the corresponding value will be 1. So let me illustrate by using the AND operator on two numbers, number 5 and number 4. The first thing we need to do is convert to the binary format of these numbers. So the binary number for 5 is 101. Binary number for 4 is 100. And what we need to do is add them together. Where the numbers match, we return the matching number. Where they do not match, we return a 0. So if we add them up, 1 and 1 match, that will give us 1. 0 and 0 matches, that gives us 0. 1 and 0 do not match, that returns 0. So the corresponding binary is 100. What we need to do is now convert this binary number of 100, which is 100, into a numerical number. and that will give us 4. I'm going to illustrate the example I just showed you on the slide on my command prompt. So if you are on a window, go to your command prompt, type in Python and press enter. That gives you access to the interactive shell. If you are on a Mac, go to your terminal, type in Python 3. So now if I do 5 and 4 and press enter, you can see that gives me a return value of 4. The next operator I want to talk about is the bitwise OR operator. This operator sets each bit to its matching value, and where there's no matching value, it sets it to the number 1. So let me illustrate how the bitwise OR operator works. Say we have a value x, and I give it a value of 0, and I give the value y corresponding 0 as well. The resulting output will be 0. So if I give this x a 0 and give the y a 1, the corresponding output will be a 1. If I feed the x a value of 1 and give the y 0, the corresponding will be 1. Again, if I give x a value of 1 and give y a corresponding value of 1, the output will be 1. So it's good to take note of the key differences between the AND operator and the OR operator. So with the OR operator, if the values match, it returns the corresponding match. Where the values do not match, it returns a 1. So let me illustrate how the bitwise OR operator works. So we're going to use that on two numbers, 5 and 4. First thing to do is convert to the binary equivalent. Binary of 5 is 101. Binary of 4 is 100. So if we add them up together, so where there is a match, it will return the corresponding output. So you can see here, the 1 and 1 matches, it returns 1. 0 and 0 matches, it returns 0. And where there is no match, in case of the 1 and the 0, it returns a 1. So we need to convert this 101, which is in binary format, into a numeric format that will return a value of 5. So back in my command prompt, if I do the OR operator on 5 and 4 and press enter, it gives me the result of 5. The next bitwise operator I want to talk to you about is the XOR operator. And what this does, it sets each matching bit to 0, and where there is no match, it gives it a value of 1. Again, it's best to explain using some illustration here. So if I give x a value of 0 and give y a value of 0, the corresponding output of x and y will be 0. If I give x a value of 0 and y a value of 1, the corresponding output will be 1. If I give x a value of 1 and then y has 0, the corresponding output will be 1. If I give x 1 and give y 1, the corresponding output will be 0. So if you observe, where there's a match, the corresponding output is 0. Where there is no match, the corresponding output is 1. So let me show you an example using 5 and 4. First, we convert to the binary equivalent. Binary of 5 is 101. Binary of 4 is 100. And then we add them up. So 1 and 1 are the same, so it will return 0. 0 and 0 are the same, so it will return 0. 0 and 1 are different, so it will return 1. So where they are matching, it returns 0. Where they do not match, it returns 1. So we now have 0, 0, 1 in binary. So to convert that to numerical, that will give us 1. So again, in my command prompt, I'm going to use the XOR operator. So I'll do 5 and then do the caret symbol and do the number 4 and press enter. You can see that gives me a value of 1. The next operator I want to talk to you about is called the NOT operator. This operator is also known as the inverter. It is used to invert the bits. For example, if I have a value x and using the inverter, it becomes a negative x plus 1. So a value that I apply the NOT operator to will end up with a negative output. So if I have 7, it should give me negative 8 and so on. So inside my command prompt, I'm going to illustrate how the NOT operator works. So you apply the NOT operator and then you add a number. So if I give this a value of 7, I press enter, it will return negative 8. Let me do another one. So if I have, say, a value of 8, that should give me negative 9 and so on. So that's how the NOT operator works. The next operator I want to talk to you about is called the left shift. This operator is used to return bits that are shifted to the left by a supplied value. So what that means, if you have a value of x, you have the bits shifted to the left by the value you will supply to the value of y. So what that means is that the y places will add zeros to the shifted places. Always best to illustrate this. It always makes more sense when you see the illustration. Let's say I have value of 3 and I want it shifted to the left 2 places. What that does, that 2 basically is going to add 2 zeros to the left of the binary value of 3. So the binary value of 3 is 11. So what that shift 2 does is going to add 2 zeros to the left of the, towards the left, shifted to the left of the binary value of 3, which is 11. So if you add 11 plus the 2 zeros, it gives you a new binary value of 1100, which is 1100. And if we convert that 1100 to a numeric number, that will give you a value of 12. So let me show you in my command prompt how the left shift works. So that's my number. And if I do left shift, so you do the left shift with less than sign and less than sign, and you do a 2. So I press enter, and you can see that has returned the value of 12. The final operator I want to talk to you about is called the right shift operator. This operator basically removes bits from the supplied value. So it will return x with the bits shifted to the right by y places. So the y places actually deletes the bits specified. So if we have a value of 3 shifted to the right by 1, what that would do, we'll first of all have to convert it to its binary equivalent. The binary equivalent of 3 is 11, which is 1, 1. And we're shifting to the right by 1 place. So what that does, it will take away one of the bits from the binary number of 3. So if you take away 1 from 11 or 1, 1, it becomes 1. So the result will be 1. So that's how the right shift works. It's good to know the distinction between the right and left shift. The right shift will take away bits, while the left shift will add bits. So let me show you an example of the right shift. So we have the number 3, and to right shift this, we do 2 angle brackets and we give it a number 1 and press enter, and that returns a value of 1. In this 2-part video series, we covered some bitwise operators and some examples to show how they work. So these are the operators on the left in this table, and then the corresponding name on the right. I'll be talking to you about operator precedence in Python. Sometimes when you are working with expressions or statements, you may have multiple operators in a statement or an expression. The way Python evaluates that is through the precedence. So if you have an operator that has a higher precedence than a lower operator, that part of the expression will be evaluated first. So let me show you a simple example. Say we have 3 plus 4 times 2. Now in this expression, the multiplication has a higher precedence than the addition operator. So what would happen, it would do the 4 times 2 first, which will give you 8. It will then add the 3 to make it 11. This is a table that shows you the operator precedence hierarchy and the name of the operator. So we have at the top of the list is the parentheses. The parentheses is always the highest. So anywhere you have parentheses in a statement or an expression, that part of the statement or expression will be evaluated first. It is also possible to have more than one operator occupying the same group or the same level of precedence. For example, here we've got the multiplication, we've got the division floor, and we've got the modulus. So they are all on the same level of hierarchy or precedence. Now, when something like this happens, if you are using an expression that has all these operators there, because they have the same level of precedence, what will happen, it will then evaluate the expressions from left to right. You can always change the hierarchy by using parentheses, because parentheses is the top of the hierarchy order. So any expression that has a parenthesis around it, that part of the expression will always get evaluated first. Let me just show you some illustrations of how the operator precedence works. Say I have a number 3 and I want to add that to 4, and I want to multiply that by 2. Now in this expression, the multiplication has a higher precedence, that is a higher order than the addition operator. So what will happen, the 4 times 2, that bit of the expression will be evaluated first, and then it adds the 3. So if I press enter, I expect to return 11. However, I can change that precedence by using parentheses. So I can do a parentheses, that's the opening parentheses, and I'll say 3, add in the number 3, and then my addition operator. So I'll say 3 plus 4, and then I'll close the parentheses, and then I'll add the multiplication. So this is same expression, but this time I'm wrapping the part of the expression that has the addition in parentheses. By doing that, the addition takes a higher precedence order. So it will evaluate the 3 plus 4 first, and then multiply the result by 2. So I expect it to give me 14. So if you add 3 plus 4 is 7. 7 times 2, it gives you 14. So it's very important to take note of the parentheses. You can use that to change the order in which an expression can be evaluated. Before I carry on, I want to explain what associativity means within Python operators. Associativity basically refers to the order in which an expression is evaluated that has multiple operators of the same precedence. And usually the operators will have to be evaluated from left to right. So it's called a left to right associativity. So let me explain how the associativity works. Say I want to print out 2 values. So inside my print statement, I would say 5 times 3. All right. And then I'll do a floor division. I'll say floor division by 2. And I'll close the parentheses. All right. So this basically will give you a left to right associativity. The multiplication and the floor division belong to the same group, so they have the same level of hierarchy or precedence. So in order to execute this, the evaluation will execute from left to right. So within the group, the multiplication comes first, even though they are all on the same order, they belong to the same group. So if I press enter here, what that happens, it will evaluate the multiplication side of things first before doing the other half, which is the floor division. So where you have operators that are of the same group, that means they have the same precedence, the evaluation becomes left to right if you're using all those operators in the same expression or statement. Of course, you can always change the order of hierarchy by wrapping the relevant part of the expression in parentheses. Please note that the associativity cannot be applied to assignment and comparison operator because of the way those operators are structured. The Python number data types are used basically if you want to work with numbers in a Python program. Now there are 2 main common ones that are normally used with Python. The first is called an integer, or int for short, and the second is called a floating point number, or a float for short. So these are the 2 different types of number data types that you can work with in a Python program. It is important that you have a grasp of the differences between the 2 so you can use them appropriately. So I'll start with integers. Integers are basically whole numbers or counting numbers. That means they can also have negative numbers, positive numbers, which includes a 0, as long as they don't have decimal places after them. So they are numbers without any decimals, and they can be numbers that are unlimited in length. Examples include 0, 100, -80, 400, and so on. As long as it is a whole number, it can be positive or negative, but must not have decimals. Floating point numbers, or a float, are basically numbers that have decimal places. So they can be positive and also they can be negative, but they must be numbers with decimal places. Examples can include 0.0, 4.5, 38.5, -27.0, and so on. So the key distinction between a floating point, a float, and an integer is the decimals. A floating point number has decimals, while the integers are whole numbers without decimals. Knowing the distinction between the two will help you when you are working with the number data types in Python. It's important to understand the difference in the data types so that when you want to use them, you get the desired result. So I am going to go into my Python shell by typing in Python in my command prompt on my Windows machine. I type in Python and I press enter. If you are using a Mac, you need to type in Python 3 and press enter on your terminal. So what I want to do, I just want to use a simple print statement to print out a number, and I'm going to use a built-in method in Python called type to tell us what class of data type it is, if it's either a float or an integer. So to do that, I just type in print and I do a parenthesis. Inside the parentheses, I'm going to use a Python method called type. It's a method, so it has to be enclosed in parentheses. Inside that parentheses, I'm going to include a whole number, and I'm going to close that parentheses and then close the inner parentheses. So if I press enter, it should tell me the class of data type, if it's an int or if it's a float. So I expect it to tell me it's an int. So I press enter. You can see here it says class int. So let's do another one that will tell us it's a float. So I'll do a print, and inside there I do a type, and for that type method I will specify, say, 20.0, and I'll close that and close the other parentheses. I press enter. You can see that the class has given me a value of float. So once you understand the distinction between the two number data types, the float and the int, it will help you decide what to use when you are building various types of application that relates to numbers. Anytime you hear programmers and developers talking about string, they are basically referring to text and characters. A string in Python is basically a sequence of character data. For the computer to recognize that you are referring to a string, you have to enclose or surround the text in quotes. The quotes can be single or they can be double quotes, but you cannot mix them. You can't start with a single quote and end with a double quote. All characters between the opening and closing quotes are all part of the string. Also, a string can contain any character you want, including spaces. They can also contain backslash and other kinds of characters you want included in your string. A string can also be empty. So you can have an empty string, just have the quotes and nothing in between the quotes. A typical example of a string is hello world. So the text enclosed in quotes is what the computer will recognize as a string. If you don't enclose it in quotes, the computer will not know what you're talking about. I have got my command prompt. If you're on a Mac, you need to open up your terminal and type in Python 3. If you're on Windows, just type in Python to access the Python shell and press enter. I'm just going to use the print statement or function to just print out some text on the screen here. So I'm just going to type in print, and inside the parentheses for the print function, I'm going to just print out a simple text and just say hello and just close. You can see I've got the opening double quote and the closing double quote, and I'll close the parentheses for the print function. Now if I press enter, that should just print out hello world without the quotes. So you can see here it's giving me the text hello world. So that's how the computer understands that you are talking about a string. So anytime you want to refer to a string in Python, you have to enclose it in the quotes, and the quotes have to be matching. You can't start with a double quote here and then end with a single. You either use two single or you use two doubles on either side. So let's do another example. If I say print and in quotes, I just have a single quote and I just say hey and just close that and press enter, and you can see it just gives me hey. So you can use either single or double quote. What if you have a character that you want to use an apostrophe? How would you represent that in a string character? So this is how you would do it. So let's say we have the print function, and inside that I want to have a string. So I can just say hey and I'll type in what. So you use what they call a escape character, which is a backslash. So I do that and then add the single quote, and I want the S, and I'll type in up, and then I'll close that. By doing it this way, it will output the apostrophe with the what's up. Because I can't use double quotes because I've already got the double quotes on either side enclosing the string. If I press enter, you can see here it says what's up. It's now using the apostrophe. The only way it was able to achieve that was by using this escape character to escape the sequence and produce this here. Okay, so that's how you use that character. All characters in a string has a specific index that is associated to them to identify their position or location within the string. So what that means is that you can tell what number a particular string is positioned within a string. And with Python, the index are zero based. What that means is that the first letter or the first character will have the index of 0. The next will have the index of 1, and so on. For example, now this H will have an index of 0. The position will be 0, and then the E, the position of the E would be 1. That's what is referred to as a zero-based index. So let's do a quick example to see how the index works in Python. So I can just do a simple print statement, and inside the parentheses I will just say hello. Okay, and then I'll close the parentheses, and then to find out the position of a specific character I need to use the square brackets. Say for example I want to find out the position of E in hello. It will have an index of 1 because the first has an index of 0. So I'll close the square brackets and close the parentheses for my print function. And if I press enter, it should return the value of E. You see, so E here has the index of 1 because it's a 0 based index. So knowing how indexes works is quite useful as well in Python. So that is it for this brief introduction to the string data type in Python. I'm going to briefly introduce you to the Python data type called a Boolean, which is also referred to as a bool. The Boolean data type basically has two values, which are true or false. When you're working with data in Python, there may be times you want to check the validity of certain conditions. You can use the Boolean data type to check if those conditions are true or false. I've got my command prompt, so I'm going to access the Python shell by typing in Python and then pressing enter, and that should give me the Python shell. If you are on a Mac, you need to type in Python 3 on your terminal. So what I want to do, I want to use a special method in Python called the type that I can use to check what class a data type is. So to do that, I just type in, I'm not going to enclose this in a print statement. I'm just going to type the method, and inside that method, I can just type in true and press enter, and that should return a class which is going to be a bool. You can see it's giving me a bool, which means it is a data type called a Boolean. So if I do the same, if I type and inside the parentheses I'll say false and press enter, again this should give me the bool. So you can use the type method to check what type of data you have. I'm going to introduce you to casting in Python. What is casting? Casting is the process of converting the value of a variable from one data type to another. Usually you can do this by using various types of built-in functions in Python. The three common functions that can be used for casting are int, which converts a value to an integer. An integer basically is a whole number. You can also use a function called float, which converts a value to a floating point number. Floating point is a decimal number. You also have a function called str, which is short for string. It converts a value to string or text. I'm going to show you some examples of casting, and I'm going to be using my Python interactive shell. If you're on the Windows, just open up your command prompt and just type in Python and press enter, and that gives you access to the interactive shell. If you're on a Mac, you can type in Python 3 on your terminal, and that will give you access to the interactive shell. So I want to start off by creating some variables. I'm going to create a variable. I'm going to call it x, and I'm going to give it a value of 70, which is going to be a string. So I'm going to put quotes around it. Anything that has a quote around it is treated as a string. So I'll press enter to that, and I'm going to add another variable. I'll call this one y, and I'll give it also a string value. So I'll do single quote and make this a negative number. I'll make it negative 20. So this, and I'll add the closing quote. So these two variables are text or strings. The values are treated as a string. Now, if I use a print statement, if I do print and I pass in the value of x plus y and press enter, you can see it's giving me 70 minus 20. That's because it's treating the values as string, that is, it's treating them as text. I can now do some casting here by converting the values into an integer, which is a whole number. So to convert the values into an integer, I can do the print statement again, and inside the print function, I'm going to nest the int function, and inside that int function, I'm going to pass in the variable x, and then I'll add my addition, and then I'll do the int function again, and inside the parentheses for that int function, I'm passing the variable y. Now, if I run this again, I should get a proper result. You can see now it's giving me 50, which is a whole number or an integer. So I was able to do some casting by converting the value, original value, which was a text value, into an int, which is an integer or a whole number. All right, so that's an example of doing casting and changing a value to an integer or a whole number. So let me show you an example of converting to a float. So I'm going to create two other variables. I'm going to create a variable c, and I'm going to give it a value of 7. I'm going to create a variable called d. I'm going to give it a value of 8. So the values are integers. If I want to convert the values into a float is a decimal number, I can use the function called float. So inside my print function, I'm going to nest a function called float, which will convert the values into a decimal or a floating point number. So inside that float function, I'm going to pass in the first variable, which is c. All right, and then I will do an addition, and I'll add the function float again and pass in the second variable, which is d. Now, if I press enter, it should give me 15.5. The 0.0 here makes it a floating point number. So anything with a decimal is treated as a floating point number. So that's an example of casting that converts to a floating point number. I'm going to do one more. I'm going to create a couple of variables again. I'll create a variable e. I'm going to give it a value of 9. I'll press enter. I'll create another variable f. I'm going to give it a value of, say, 8.5. So the values are the first value for e, that's an integer, a whole number, and the value for f is a floating point number. To convert the values into a string, I need to use a function called str. So I'm going to type in print, which is a print function, and inside the print function, I'm going to add the str function. So inside the parentheses for the str function, I'm passing the first variable e. Okay, and then I'll do a comma. I'll add a text that says and I'll do a comma after that. Okay, and then I'll add another str function, and inside the parentheses, I'll pass in the variable f. Okay, and then I'll do a comma, and I'll add another text that will be added to the variable values. So that is it. I'm just going to close that, and I'll close the parentheses. So I press enter, and you can see here it says 9 and 8.5 are strings. So I was able to convert the values of the variable e and f into string by using the str function. So that's basically what casting is, when you change the value of a variable from one data type to another. I'm going to introduce you to what lists are in Python. What is a list? A list is basically what the name says. It's a list. So it's a collection of data which can be of mixed type. What that means is that the content of the list can be a string, which is a text. It can be a number. It can also be a Boolean value. So the data type can be either the same or they can be mixed. The items in a list are ordered by their index, and they're also changeable. When I say they're ordered by their index, the index refers to the position of the elements in the list. And also the elements can be changed. So you can have items in the list that you can later change. Lists are created by using square brackets. So you have the opening left square brackets, which opens up the list, and then the closing right bracket, which closes the list, and then you can have items in the list. You can also have an empty list just with square brackets and then nothing inside the list, which you can populate at a later time. The items in a list can be accessed by the index. The index refers to the position. So if you have a list that contains 5 items or values, the very first item will have an index or position of 0. The second item will have an index or position of 1, and so on. Each item in a list has to be separated by commas. So you separate the values in a list with a comma. A list is very useful. It allows you to store multiple values in one container or object. We are going to be creating a list. To create a list, you just need to give the list a name. You use the equals to, and then you assign the values in the list. So the left square bracket opens up the list, then you add the values in the list. You separate each value with a comma. If it's a text or a string, you need to enclose it in quotes like I have done in the illustration. And then you use the right square bracket to close the list. So let's create a list. So to create a list, I'm going to be using the text editor called Atom. And I've created a new Python file, which is this file here on my desktop, and I've called it my list. So you can create a file, a Python file, and then just save it anywhere. Your desktop might be easier, like I have done. And then this is the file. So this is where I'm going to be creating my list. To create a list, you start with a name. Always give your list a descriptive name to reflect the type of elements that the list is storing. So I'm creating a list called animals, and I'm going to set that to the different values. So I can just say the first value in there, I can say a bear. I'll do a comma to separate the values. I'll add another value. I'll say maybe a tiger. I'll do a comma, add another one. Let's say a lion, and so on. You can add as many items as you want in a list. I'm going to add, let's say, a panda. Let's add one more, do a comma, and I'll make this one an elephant. So these are now elements in my list. So to save the file, I'll just do Control S on Windows. If you're on a Mac, you do Command S. You can use what is called a for loop if you want to loop through the elements in the list and print them out. You can loop through them, and the way you could do that, you just do a for, and you say for x. Let's represent the name of the list as x. So we can say for x in animals, and then you add a colon, and then you use the print function or print statement and pass in that value of x. So I'll just do Ctrl S to save. I'm going to open up my command prompt, which is this, and to access this file here, which I've saved, I'll just call it by its name, which is mylist.py, and I'll press enter. And you can see here is listed all the elements of the list. So I'm just going to clear my console by typing in CLS. If you're on a Mac, you can just type in clear, and that will clear the console or terminal. You can also use the print function on its own just to print the list. So I can type in print, and inside the parentheses for the print function, I just pass in the name of the list. And what that would do, it will just print exactly as it is. So I'll do Ctrl S to save. If I open up my terminal, type in the name, which is mylist.py, and press enter. When you execute code, the code will execute in the order you've written it. So it's printing out each item first using this block of code, and then it goes on to this block of code and just prints which is this block here. It prints the entire list just the way it was created. So that's basically how to create a list in Python. I will be showing you how to access the elements of a list. So you can access the elements or values in a list by using the index. The index basically refers to the position of the elements in a list. With a Python list, the index are 0 based. What that means, the first element or item in the list is given a position of 0. So let's take a look at an example. So let's look at this list here, which is called animals. So with this list, if we want to access, say, the bear, this will be position 0. And this will be position 1, and this will be position 2. So it is a 0 based index. So let's take a look at how we would do this. So I've got some code here from a previous video. So I'm going to comment out some lines here. So because I don't want them to be printed, I want them to be ignored. So I'll just comment it out. All right, so these are all commented out now. So if I wanted to access the bear from this list, this is how I would do it. I'll type in print, and in parentheses, I refer to the name of the list. So the name is called animals, and then inside that, I add a square bracket and I type in a 0. So the 0 is the index. So what that means, when this prints, it will just grab the 0 index, which is the first item or element in the list, which is this called bear. So I'm going to save that. And if I open up my command prompt and just type in the name of my file, which is my list.py, and press enter, and you can see it's giving me the value of bear, which is the first item on the list. Now, if I wanted to access the tiger will have an index of 1. I'll have to replace the 0 with a 1, and so on, depending on how many items you have on the list. If you notice, because I have commented out blocks of my code, the bits I have added a comment to, it has not been displayed on the screen. So comments are quite useful if you want to try different things and you don't want all the code in your file to be acted upon. So it blocks out the aspects you don't want to be executed or printed on the screen. You can also access elements within a list from the back of the list. So if you're doing a 0 based index, it would access the element from the first. Now, if I change this from 0 to say -1, -1, what that will do, it will access from the back of the list. It will now give me elephant rather than bear. So let's check this out. I'm just going to save the file and open up my command prompt and execute. You can see now it's giving me elephant instead of the bear because I have used a negative. When you use a negative index, it gives you a value from the back of the list. Another thing you can do with accessing list items is that you can access a range. For example, if I wanted to access, say, from this to this, you can specify that. Or if you want to access, if you want to start listing from a certain index, you can. So this is position 0, this is position 1. Let's say I want to just print out anything from position 1 and not 0. So the way I will do that, inside my print statement, I will just do 1 and I'll do a colon. And what that will do, it will print out everything apart from the position of 0. So let's check that out. And I'm just going to type in the name of my file, which is my list.py, and press enter. And you can see it prints out tiger, lion, panda, and elephant, but it skips the bear. So by using the index number and the colon, it will print everything after that index, as you can see here. Another thing you can do is you can specify a range. So let's say I only want the tiger and the lion printed on the screen. So instead of just doing the 1 and the colon, I can come here and add 3. So this is position 0, position 1, position 2, position 3. What this will do, it will print just position 1, position 2, but it will not print position number 3. So let's save that and check that out inside our terminal or command prompt. So I just type in the name of my file, which is my list.py, and press enter. And as you can see, this has just printed out the tiger and the lion. The tiger is position 1 and the lion is position 2. It doesn't print position 3. So I'm giving it a range. So I say print, grab the values from position 1 and 2. All right, that's what that does. And the final thing I want to show you in this video is how to modify the list. So if you want to change the item in the list, let's say this item called bear, I want to change that to a dog. The way I would do that, I just type in the name of the list, which is animals, and I'll add the square bracket and add the index of what I want to change, which is the bear. It has an index of 0. And then I'll use the equals to sign to set a new value for what I want to change it to. So let's say I want to change the value of the bear to the dog. That's how I would do that. So I'll do Control S to save. If you're on a Mac, you can do Command S. Now I can test this. If I do a print, and inside that print, I type in the name of my list and I'm passing the index of 0. Now this index of 0 will no longer say bear, it should now say dog, because I've made a modification to that name. So let's save that and let's go back into my command prompt. I type in my list.py and press enter, and as you can see, it's giving me the value of dog. So when you're executing code, it will do it line by line. So this here is printing out this code here on line 5, that's this line, and then this print here on line 7 refers to this dog that I'm telling it to grab the value of that index 0. So that's basically how you can play around and access values and also modify values within a list. I'm going to introduce you to what tuples are in Python. What is a tuple? A tuple is a list that cannot be changed in any way. It means they are immutable, they cannot be mutated or changed. The only thing you can do to a tuple once you've created it is delete it. You can create a tuple by giving the tuple a name and just adding parentheses and placing the values inside parentheses. You can also use what is called a tuple constructor to create a tuple. Once you've created a tuple, you can access the individual elements within a tuple by using the index number. The tuples have a zero-based index. What that means is that the first value in the tuple is given an index of 0, the second is given an index of 1, and so on. Let me show you how you can create a very basic tuple with just a name and parentheses. I am using the text editor called Atom, and I have created a empty Python file on my desktop. I've called it my_tuples, and I've given it a .py extension. That's what makes it a Python file. So now let me begin by giving my tuple a name. Try to give your tuple descriptive name that illustrates or tells you what it is the tuple is storing. So I'm going to create a tuple. I'm going to call it fruits, and I use the equals to sign and then add my parentheses. Inside my parentheses, I will now add the elements or the values I want to be in my tuple. So that is grapes, and do a comma and add another value. I'll say apples. Always separate the values with a comma. I'll just add one more, and I'll make these berries. So you can have as many items or elements as you wish to do so. So now this basically creates the tuple. So I can just do a Ctrl S to save this file. If you're on a Mac, you can do a Command and S to save it. Once you have created a tuple, you can use what is called a for loop to loop through, that is, go through the list and then print it out on the screen. So let's do that. So to add a for loop so that we can print the elements of our tuple, we just type in for, and I'm just going to use X to represent the values inside the tuple. So I'll say X in fruits, okay, and I'll do a colon and press enter. Then I will use the print statement to print the values, and I'll just say X. And what this should do, it will print out the values or the elements on the screen. So I'm just going to do a Ctrl S to save. Now if I open up my command prompt, this is my command prompt. If you're on a Mac, you need to open up your terminal and navigate to where you've stored your file. I've stored my file on my desktop, so I've navigated to it here. You can see my desktop. So all I need to do is just type in the name of my file, which is my_tuples.py, and that should print the elements. You can see here it's printed all the elements, is looped through and then printed them on the screen. So that's how you can loop and print elements from your tuples on the screen. You can access individual elements within a tuple by using their index number. So let's say I want to access the element berries from this fruits tuple. This is how I would do that. I'm going to use a print statement to print it out on the screen. So I'll do print, and inside the parentheses I pass in the name of my tuple, and then within that I'll add the square bracket and add the index, because the first element is grapes, so that will have an index of 0, apples will be 1, and then the berries will have an index of 2. So I'm targeting the berries. So I'm just going to put a comment here on line 2 because I don't want that to be printed. I don't want that line of code to run. So the only line of code I want to run is line 4 and line 1. So once I've done that, I just come here and do Control S. Now, if I open up my terminal and just let me clear my terminal, and then I type in the name of the file, which is my_tuples.py. I only expect it to print out the value of berries. As you can see here, is printed out berries because that's what's inside my code editor. I've commented out line 2, line 3, so the interpreter will ignore those 2 lines. So that's basically how you can access individual elements within a tuple. I'm going to show you how to create a tuple using a tuple constructor. This involves using double parentheses. To create a tuple using a tuple constructor, you first of all need to give the tuple a name. So I'm going to create a tuple. I'm going to call it animals, and then I use the equals to, and then I'll type in the word tuple, and then I'll have double parentheses, and inside the inner parentheses is where I will add the values I want to be in my tuple. So I'll say lion, I'll do a comma, add another one, I'll say tiger, I'll do a comma and add one more. Let's make this one a bear. So that basically creates the tuple using a tuple constructor. So again, if we want to print this out on the screen, we can just use a for loop to loop through them, or we can just use the print statement to just print the tuple. So we can just say print, and inside the parentheses for the print statement, we just type in the name of the tuple, and then we save as the file using Control S. Now, if I open my command prompt, if you're on a Mac, you need to use the terminal. So this is my command prompt. I'm just going to type the name of the file, which is on my desktop. You can see I've navigated to my desktop. So I just call the file, which is called my_tuples.py, and that should just print out the values of the tuple. So you can say it's got lion, it's got tiger, and it's got the bear. You can also access the individual values in the tuple again by using the index. Lion will have an index of 0, tiger will have an index of 1, and bear will have an index of 2. There is a special method you can use. If I wanted to find out the length of the items in my tuple, I can just do a print statement. I'll do a print, and inside the parentheses I type in the length method, and inside that I will just add the name of my tuple, which is animals. So I'm just going to comment out line number 2 because I don't want line number 2 to be printed out. I just want the line number 3 executed. So I just do Control S to save, and I open up my command prompt. So I'm just going to clear the screen, and now I'll type in the name of the tuple, which is my_tuples.py. I'll press enter, and you can see here it's giving me is returned 3, which means the length of the elements in my tuple is 3. So lion 1, 2, 3. Once you create a tuple, you cannot modify it. The only thing you can do is delete it. If, for example, if I try to add to my tuple, I will expect to get an error. So if I say animals, which is the name of my tuples, and I will use a method called add. So I'll do add, and then inside the parentheses, I'll add the value of what I need to add. So let's say I want to add dog to that tuple. That's the way I will represent it, but I expect the code to error because you cannot change a tuple once you've created it. So if I do another print statement here and say print animals, I will expect this line of code to error because you cannot change a tuple once it has been created. So let me open up my command prompt again, and I just type in, that's the name of the file, which is this file here. If I press enter, you can see it will execute this line of code, which prints the length, which is 3. But you can see the line 4, it did not execute. It did not execute line 5 because of the error. Let me show you what the error says. It says attribute error. Tuple object has no attribute add. Okay, so we cannot add to a tuple. You cannot also change the value. So let's say if I put a comment here, and then I come here, I type in animals, all right, and I say let's say we have lion on index 0. I want to change that to, let's say, a cheetah. Not sure if that's the right spelling, but okay. And then I'll save, Control S. Now, if I try to run my Python file again, I expect there to be an error from line number 5 and 6 because I'm trying to modify an existing value, but it's not going to let me do that. So I press enter. You can see it prints 3 here, which is line 3 of the code. It executes that. Okay, no problem. Line 4 I commented out. Line 5 and 6 is giving me an error. You can see it says here, type error, tuple object does not support item assignment. So I'm trying to reassign a different value to an item that's already in the list. It will not do that. The only thing you can do to a tuple once you've created the tuple is delete it. And you can delete it just by using the keyword del followed by space and then the name of the tuple. You can see on line 6 here, I am deleting the tuple. I've also commented out all the other lines of code. That means those block of code will not be executed. So I'm just going to do a Control S to save. Now, if I run this file, I expect to get an error to tell me that that does not exist. All right, so you can see here, it's telling me here, name error, animals is not defined. And that is because I have deleted the tuple on line 6 here. I'm going to introduce you to a Python set. The set is a type of data structure in Python. What is a Python set? A set is basically a collection of values. The values in a set are not ordered. That means they are not in any particular order. And the values in a set are not indexed. This is because they are not ordered, so it's difficult to index them. The set allows you to add values to it. However, you cannot change the values that are already in the set. This is very important. You can add values to a set, but you cannot change existing values. One way of creating a set is by giving the set a name. Try to give your set a descriptive name that reflects the type of values it stores, and then you add curly braces, and inside the curly braces is where you indicate the values that are going to be stored in the set. I have got my text editor opened. I'm going to be using the text editor called Atom. I've also created a Python file and I've called it myset.py. So that's the name of the file. It must have a .py to make it a Python file. So I'm going to create a set. So I'll give the set a name. I'm going to call it fruits, and I use the equals to assign values, and the values has to be placed inside curly braces. So I'll now add the values. The first value I'm going to add is going to be grapes. You separate each value with a comma. And now I'm going to add another one called apples. I'll do a comma, and I'll add one more, and I'll call this berries. So that basically creates a set. It is difficult to access the individual elements in a set because they are not indexed, so they are not in any particular orders. The orders can change, so you can't access the value from the index because they are not indexed. However, you can loop through and print out all the elements in a set, and you can do that using the for loop. So to do that, I can just say for x in fruits, okay, and then you add the colon. So the x represent each value. I can just say print x, and what that will do, it will print all the elements inside the set. So let's see how that works. Let me run this Python file inside my command prompt. So I've navigated to my desktop, which is where the Python file is. So in order to run the file, I just call it by its name. So I'll say my set.py, and I'll press enter, and you can see it prints out all the elements inside the set. Another way you can create a set is by using a constructor function. So the constructor basically is a special type of function used to create objects. So if I wanted to create a set called animals, this is how I would represent it. When you're using the constructor function, notice you have double parentheses. So I'm going to create a set using a constructor function. So you start with a name I want to call it. I'm going to call it animals, and I'll say equals to, and I'm going to have double parentheses, and inside the inner parentheses I'll specify the values that I want to add to the set. First value is a lion. Second value I will say tiger. I'll add one more, and I'll make this one a bear. So I basically created another set by using a constructor function. Now, if I wanted to print the values of this set on the screen, I can do what I've done here on line 2 and 3. Just do the same thing here, and that will loop through and print out the elements inside that set. If you want to count the values in a set, you can do that using a special built-in function called len. If you just add the name of the set inside the len function, that will print out the values in the set. So let's try and print out the values inside the set called animals. So the way we'll do that is to do a print, and inside that print function we add another function called len, and inside that len function we'll pass in the name of the set, which is animals, and we just do Ctrl S to save on the window. If you're on a Mac, just do Command S, and that will save the file. So now if I run my file again, which is my set.py, it will execute the code. You can see here, this print x here prints all the values from the first set, which is fruits. And this line of code 3 here basically is this here, where it's printing the length of the values in this set called animals. You can see there are 3, the bear, the tiger, and the lion. That is what this value 3 represents. I'm going to introduce you to the Python data type called dictionary. What is a Python dictionary? A real-life dictionary holds words and their meanings. A Python dictionary is similar, but it holds key value pairs. Key value pairs basically mean all the values inside the dictionary will have a unique key and a corresponding value. For example, you could have a key that is called fruit, and the value would be a name of a fruit, for example, apple. So that's what it means by key value pairs. So they come in pairs. You have the key and then you have the values. The values can be changed. That means they are mutable. Also, the values must have unique keys. So you cannot have duplicate keys for the same values. The keys are unique. You can also store mixed data types. So you can store strings and you can also store numbers inside a dictionary. You can mix the data types or you can have a specific data type. There are different ways you can create a dictionary. So let me walk you through a couple of ways. I'm going to be using the text editor called Atom, and I've created an empty file on my desktop called mydict, and I've called it mydict.py. So any code I write here will be a Python file. First thing you need to do is give your dictionary a name. Try to give it a name that reflects what it is you are storing. So I'm going to call my dictionary my car, and then I'll add the equals to, and then I'll add my curly braces, and I'll tab in between to separate the curly braces, and I will start adding the key. So I'll start with the key first. So the key, I'll type in brand, and after the key I do a colon, and I then specify the value. So my value, I'll say Range Rover Sports. Okay, that is one key value. This is the key, which is unique, and this is the value. The value can change, but the key has to be unique for each value. So I'm going to tab and add another. So you need to separate each of the key value pairs with a comma. So I'll add a comma and come down here and do a different one. So I'll add another key. This time I'm going to give this a model, make this model, and I will add the colon and give it a value. The value, I'll say HSE. I'll do a comma and I'll add one more key value. This time I'm going to make this one the year, make it in lowercase, year, and then I add the colon and I'll add the year. I'll say 2017. Notice this is a numerical data type, so I don't need to put quotes around it, and I don't need to add a comma because that is the last value, so no need. If I'm adding more, then I use a comma to separate each key value pair. So that is basically it for creating a dictionary. I've just created a basic dictionary. So if I wanted to print this dictionary, all I have to do is type in print, and in parentheses I specify the name of my dictionary, which is called my car, and I'll save my document. I'll do Ctrl S to save it, and then I'll run it inside my terminal or command prompt. So I've got my command prompt here, and I've navigated to my desktop, which is where my Python file is, and that's the name of the file. So if I just press enter, it should execute the code. You can see here it's printed out my dictionary. That is a key, that's the value, that's another key, that's the value, that's another key, that is the value. Another way you can create a dictionary is by using a dictionary constructor function. A constructor is basically a special function that you can use to create an object. So to create a dictionary using the constructor method, you first of all have to give the dictionary a name. So I'm going to call mine my greens, and you do the equals to, you type in the word dict, okay, and then in parentheses you then specify the key and then the values. So this is how you do it. You first of all type in the key. It's a bit different when you use the constructor method. So you use the key, and then once you specify the key, you add the equals to, and then you enclose the values in quotes if it's a string value. So I'm going to say green apples, okay, so that is 1. I'll do a comma and I'll add another key. The key this time is going to be vegetables, okay, that's the key, and I'll do equals to, and then I'll add value. I'm going to enclose that in quotes as well, and the value will be kale. I can add a print function and then print out what's inside this new dictionary I created. All I need to do is just pass in the name of the dictionary, and I'll save the file and open up my command prompt. That's my command prompt. So I'll just type in the name, and you can see here that is my first dictionary, and this is the second dictionary I created using the constructor function. So that's basically how you create dictionaries. Functions are an important part of programming in Python. They help us keep our programs organized and makes it possible for us to reuse the code we write. There is a principle in software development which all good programmers try to follow. It is called DRY principle, D-R-Y, which stands for don't repeat yourself. In other words, it means don't write the same code twice. Now, functions can help you avoid writing the same code twice. So what are functions? Functions are basically a collection of computer code which can be executed anywhere in your program and also used over and over again. So they are reusable. And these block of codes always do something specific. The beauty about functions is that they are reusable. They execute or run when they are called, and you usually call them by their name. So when you create a function, in order to activate it, you need to run it or call it by the name you have given it. They can have parameters. Parameters are basically variables that you define inside the function parentheses, and also they can have arguments. Arguments are the actual value that you give to the function when you call the function. They can return data as a result. So if you want the functions to return data, they can also do that. Functions are built in, and they can also be custom created. Example of the built-in functions we have used so far is print. The print is a function which allows you to print stuff on the console. You can also create your own custom functions, which are called user-defined functions. Creating a function is fairly straightforward. Before you create a function, it's good to think of a descriptive name that you want your function to have. the naming convention for a function is the same as the naming convention for variables. To create a function, you start with the def keyword, which indicates you're about to create a function, and then you give the function a name, followed by parentheses, and then the colon. The colon basically tells the Python interpreter that you're about to start a new line of code. So whatever code you write here is the block of code that gets executed when the function is activated. When you define functions, inside the parentheses can be empty, or you can pass in what is known as parameters. Parameters are basically variables that you define inside the function. When you activate your function, you can also give it a value that matches the parameter you set. That value is referred to as an argument. So I've already got a directory. I'm just going to right click on the directory, click on new, and click on Python file. I'm going to call it functions, and it will automatically append it with a .py file extension. So I'll click OK, and that will create the file called functions.py. Create a function. You start with the keyword def, you do a space, and then you give the function a name. I'm going to call my function sum, and then you add the parentheses. Inside the parentheses, you can add parameters, or you can leave the parentheses empty. So I'm going to add a couple of parameters, which are variables. I'm going to call this x, I'll do a comma, and I'll call this y. And once you're done, you add a colon. The colon basically tells Python that you want to start a new line of code. So here now is what is called the function body. This is the code that will execute when the function is activated. So I'm just going to say x plus y. So that is it. We have created a function. Now the x and y are known as parameters. Okay, so when this function activates, it will print the value of x plus the value of y. Once you have created your function, the function does nothing until the function is activated. Now the process of activating the function is called calling the function. It also has other names. You can call it executing the function or invoking the function. So any phrase you hear relating to call, running, executing, invoking, they all mean the same thing. And when you call a function, you call it by its name and you add the parentheses. Now, if you have defined some parameters during the function definition, then you need to pass in some arguments when you call the function. Those arguments are the values that you give for the parameters you have set in the function definition. So to activate or call this function that we've created, we need to call it by its name, and the name is sum. So we'll say sum, and then we add the parentheses. Now notice that we had two parameters defined inside the function. We've got x and y, so now we need to supply the values for x and y. Those values are known as arguments. So if I say 4, 5, and that basically calls the function, passing those two values for the parameters I have set, and then it will execute the function. So let me save that and then play the file. So I click on play, and you can see here is returned a value of 9. Okay, so is added because here I've said print x plus y. So when I call the function, I passed in two values, 4 for x and 5 for y, and it returned the value of 9. So that's how you call a function once you have defined the function. It is good to know the difference between parameter and argument. Sometimes this can confuse beginners. A parameter is actually like a variable that you define inside the function's parentheses, while an argument is the actual value that you pass or give to the function when you call the function. So in our function, x and y are the parameters, while the number 4 and 5 are the actual arguments for those parameters. If you want a function to return a value, you need to use the return keyword inside the function definition. So let's create a basic function. So I'm going to create a function called sum. And inside the parentheses, I'm going to give it two parameters, x and y. And once I've done that, I will add my colon and press enter. And then instead of adding a function body or the code that will execute, I can just add a return, and I can tell it what to return. I want it to return the value of x plus y. So that's basically how you use the return keyword. To call this function to return a value, I can use the print function. So I can say print, and inside that print function, I can add the name of my function, which is called sum, and I'll add a parentheses and then passing some arguments for the parameters. So I'll say 4, 5. And I'll just create another one below. I'll say print, and again the name of my function. I add the parentheses and I'll just pass in two other arguments. So now what this should do when I play the file, it should print out or return the value of 4 and 5. So which are these two are arguments. These two are arguments for the parameters. So let me click on the play button, and you can see here it's returned some value. So when I call the print function, I passed in the function, which is sum, and then passed in some argument 4 and 5. I said here in the return statement to return the value of x plus y, which is what it has done here. X is 4, y is 5. So if you add them together, I give you 9. Same thing here on line 5. 8 is x and 4 is y. If you add them together, it gives you 12. So that's basically how you use return keyword inside your function definition. What is a default parameter value? This is the value that a function uses when it is called without passing it a value. So when you call a function without a parameter, it uses the default value. Only parameters at the end of a parameter list can have a default value. This is because the values are assigned by their position. So if you have several parameters, you can only give the last parameter in the list a default value. In the first example here, now this is a proper way of assigning a default parameter value, because this has two parameter A and parameter B. Because of the way the values are assigned by their position, you can only give a default parameter value to the last parameter inside the function definition. So this is the proper way, and this one is not the right way, because you see here I'm giving it a default value here when it should be at the end of the parameter list. Let's create a new function. So I'm going to create a function called student underscore names. And inside the parentheses, I'm going to define just one default value. So I'm going to call it names. Names is going to be the parameter. I'm going to use the equals to sign to assign a value to the parameter. I'm going to call it Boolean. So that is the parameter names, and this is the default value. So I add my colon and tab, and I'll start a new line of code. So inside my function body, I want to add a print function, and inside that print function, I want the print function to say hello plus the student's name. So I will just do a space and add a addition operator, and then add the name of my parameter. So my parameter here is called names. So what I'm saying, once I run this code, any values I pass to it, it will print out hello plus whatever name I passed to the function. So let's try and call the function and pass it some arguments. So to call the function, you call the function by its name, which is called student underscore names. And then inside the parentheses, I can pass in different names. So let's say for this one, I'm going to leave it blank. I'm just going to copy this a couple of times. So inside the names here, I'm going to add in some strings. Because they are strings, you need to enclose it in quotes. So the first one here, I'll say John. And for this one here, I'm going to add Jane. All right. So notice the first one here, line number 5, I have not passed in any value. So what's going to happen when I execute this code is going to use the default value that I have set inside the parameter here that I defined. So let me save my code by pressing Ctrl and S. If you're on a Mac, you can do Command and S. So once you've saved your code, play the file. So I click on play, and you can see the output. When I call the function, I did not pass in any value for the first student name, and it then used the default value, which was Boolean. Line 6, I passed in the name John, so it says hello John. Line 7, I passed in the name Jane, it says hello Jane. So inside the function body, I did say I wanted to print the word hello plus whatever names I have supplied. So the names I've supplied when I called the function was John and Jane. I didn't supply a name for Boolean because Boolean here is a value, the default parameter value for this names variable. So that's basically how you use parameter default value. The key thing to note is that where you have several parameters defined, you can only give the default value to the last parameter in the list. So if you have several parameters, you separate them by a comma, and you can only add a default value to the last one. This is because of the positioning. Okay, the values are assigned by position. What are keyword arguments? Keyword arguments allows you to specify what parameters you want to use from a list of parameters that you define inside your function. You do not need to worry about the order of the arguments. Keyword arguments allows you to give values only to the parameters that you want, provided that the other parameters have default argument values. So let me illustrate by just defining a function here. I'm going to define a function I'm going to call it more underscore num, and inside the parentheses I'm going to pass in some parameters. So I'll say a, that'll be the first one, and then I'll say b equals to 7, which is a default parameter value, and c equals to 10. So I'm going to add my colon and tab down, and I'll add just a simple print function, and inside the print function I'm just going to add a text that says a is, and I'll do a comma, add the parameter of variable a, and I'll do another comma, I'll add another text, and I'll say and b is, I'll do a comma and add the variable b. All right, I'll do another comma and I'll add another text, and I'll say while c is, I'll do a comma and then add the variable c. So if you notice in the definition, only the parameter a has no default argument value. The parameter b and c have default argument value. So now if I wanted to call this function, I can call it by its name. I'll say more underscore num, and then I'll pass in some values. So I'll just say 3 and 7. I'll do another one. I'll say more underscore num, and I'll pass this value, say 23. I'll say c. I'm changing the value of c now. I give it 17, and I'll do one more. I'll say more underscore number, and inside the parentheses I'm going to change the value of c again to 40, and I'm going to set the value of a to say 80. Note that you can specify the argument values in any order. So let me play my file and then you can see the output. So this is the output. You can see here the first calling of the function here on line 4. I passed it 2 arguments. The first one here is for, you can see here it says a is 3 and b is 7, while c is 10. I've given it 3, and that 3, it gave that to the variable parameter a, and the b is for 7, while the c is using the default value of 10, the default. All right, and then on the line 5 here, where I've called the function again, I have changed the value of a, and I give the a 23 because I didn't set a value here, so it's easy for me to just give it any value. Remember that you use the equals to assign a value. So a here is 23, b is still 7, but I changed the value of c to 17. You can see it says while c is 17. Use the equals to sign to change the value. Line number 6, where I call the function again, I change the value of c to 40 and value of a to 80. And you can see here it says a is 80, b is still 7, while c is 40. So notice the order of execution. You can specify the argument values in any order as I've done here. However, when it prints in the order in which the parameter has been defined, but the way the argument is supplied, that order it doesn't really care about. It will print out in the order of the parameter, but the argument parameter can be passed in any order. I'm going to illustrate how you can create a function inside another function. That process is called nesting. In this video, I'm going to use the text editor called Atom to nest my function. So with Atom, to create a new file is fairly straightforward. You just click on the new tab and click new file, and then you name the file and save it wherever you want to. So I've created a file called functions2 and I've saved it on my desktop. Sometimes when you save files, it also puts the directory where the file was saved on this side on the left hand bar. So you can always remove it just by right clicking, and there is an option to remove project folder, and that gives you more room to work with. So let's start off by defining a function. So to define a function, just type in def space followed by the name you want to call the function. I'm going to call my function my num, and I am going to give it a parameter. I'm going to call the parameter a, and I'm going to add a colon and tab down, and then I'm going to define another function. This is going to be the function I am nesting. So I'm going to type in def again to create the function. I'll do a space and I'll give the function a name. I'm going to call it num, and inside the parentheses I'm going to pass in the parameter a for that function. So I'll do a colon and I'll tab down. I want to add a return statement so that some kind of expression is evaluated. So I'll say return the value that is supplied for a plus 1. So whatever value is passed for the parameter a, I want 1 to be added to it. Indentation is very important, so make sure that your code is well indented. If not, you will get errors. So the next thing I want to do is, after this return, is create a variable. So I'm going to create a variable that is going to return the value of that variable. So to create the variable, I'm just going to indent back so that I'm on the same line of indentation as this nested function. So I'm going to create a new variable called result, and I'm going to set the result to equals to my function called num, and I'm going to pass in the parameter a. Next thing I want to do is return the value of that variable called result. So I'm going to type in result. I'm going to type in return space result. So whatever the value is, I want the return statement to return that. Next thing I want to do is do a print statement. Again, notice the indentation. So I've got my print function is going to be on the same indent level as this outer function. So I type in print, and inside the print function, I am going to pass in the name of my function, which is the outer function, which is num, and I'm going to pass in an argument for the parameter a. So I'm just going to give it a value of 4, and then I'll save that and then run this file. The name of my Python file is called functions2, which is on my desktop. So inside my command prompt, I have navigated to my desktop. So in order to run the content of the file, all I need to do is call the file by its name. So I'll say functions2.py and press enter, and that will execute. You can see here it's giving me the result here. So the return says whatever value I supplied for the parameter a is going to add 1 to it. So here in the print statement on line 6, I've supplied 4 as the argument for the parameter a, and this returns on line 3 here has added a 1 to it, hence we get 5. So you can see here I've nested a function on line 2 here inside another function on line 1. So that's basically how you can nest functions, which is creating a function inside another function. Anonymous functions are also called lambda. They are defined by using the lambda keyword. So when you define anonymous functions, you don't use the normal def function definition. Anonymous functions can take several arguments, but they can only have the one expression. Let's create an anonymous function. So I'm just going to say a, and I'm going to set that to equals to an anonymous function, which you define with the keyword lambda. All right. And then you can pass it several parameters. So I can say b, and I will say b plus a, or b plus 4. I give it a value of 4. And then I can just do a normal print. I'll say print, and inside that print function I'll pass in the value of a, and in the parentheses I will add 4. So now let me save that and then run that so that you can see what the output looks like. So I click on play, and you can see here I've said print a, which is 4, because here a is the lambda here, and I'm saying b equals to b plus 4. Now this is a, and I'm giving b the value of 4. So it's saying ba, which is the function. I'm calling the function now, which is a, that's the anonymous function, and passing it a value, an argument of 4, which is for this parameter called b, and it's adding the value I've passed to 4. That's what gives you 8. Lambda can also take multiple arguments. So let's define another lambda function. So c, and I'll say equals to lambda, and I'll pass in some parameters. I'll say d, comma e, and then I would say d plus e. I'll add a print statement. I'll say print, and inside that print function I'll reference the anonymous function, which is c, and inside the parentheses for that anonymous function I'll pass in 2 arguments. I'll say 7, 8. So these are the arguments for the function. I'm just going to comment out line 1 and line 2 of my file so that those block of code do not run. So now I'm just going to play this file. I'll click on play, and you can see here it's giving me 15, which is when you add d plus e. This is a function here called c. I'm passing it 2 arguments for the parameter d and the parameter e, and when you add them together it gives you 15. You can also use lambda functions when an anonymous function is required for a short period inside another function. So let me show you an example. So I'm going to create a function. I'm going to call it ghost underscore numbers, or number, and inside the parentheses I'm just going to pass in the parameter n. and I'll add my colon. I'll tab down. I'm going to add a return. I'm going to say return lambda f colon, and I'm going to say f asterisk n. So this function here takes one argument, and that argument is going to be multiplied by an unknown number, okay, which is the n there. So I'm going to create a variable. I'm going to call it double underscore num, and I'm going to set it to equals to the function I created called ghost underscore number, and I'm going to pass in a value of 2 inside this function here called ghost number. So this variable is going to be equals to this function, which is this function I defined above. So now to call, I can do a print function on this variable on line 4, and what that will do, it will double any number I give it, because that's what I've said here on line number 2. So I can just do a print function. I'll say print, and inside that print function I'm going to reference the variable called double underscore number, and inside that parentheses I'm going to give it a value of 20. So what I expect is 40 back, because it's going to multiply it by n. The n is the 20, which is the unknown value I have now supplied. So let's run that. I'll click on play, and you can see here is giving me a value of 40. So anonymous functions can be quite useful sometimes, especially if you want to use it just for a short period of time inside another function like I have done here. Python decorators. What are decorators? A decorator is a design pattern in Python that allows a user to add new functionality to an existing object without modifying its structure. And the objects could be a function, a method, or a class. A decorator is usually called before the definition of the object we want to decorate. So before you can call a decorator, you have to apply it to the object you are decorating. If it's a method, you add it before the method. If it's a function or if it's a class, you add the decorator preceding that object. Decorators usually have a symbol in Python followed by the name of the decorating object. Having a basic knowledge of functions will help you understand how decorators work. I am going to illustrate how to create a basic decorator, and the decorator that I'm going to create is going to convert a sentence into uppercase. So we're going to achieve this by defining a wrapper inside an enclosed function. I am going to be using the Pycharm IDE to illustrate how a decorator works. So inside my Pycharm IDE, I'm going to create a new file. So I've already got a directory here. So I'm just going to right click on the directory. You can see I've got some other files here as well. So I'm going to right click and go new and click on Python file. And I'll just give the file a name. I'm just going to call it Deco for short. I'll call it Deco, and it will append it with a .py file extension. So I'll click OK, and that should create a file called deco.py, and that's the file here listed. So I'm going to start off by defining a function. So to define a function, you type in def space, and then you give the function a name. I'm going to call my function my underscore decorator, and inside the parentheses for that function, I'm going to pass in a function. Next, I need to add my colon and then press enter to indent my code. Next thing I want to do is define another function, which is going to be a wrapper function. So I'll say def, and I'll call it wrapper, and I'll add my parentheses and also add my colon, and then press enter to indent that function. So inside this wrapper function, I'm going to add a variable, and I'm going to call it my function, or my func for short, and I'm going to set that variable to equals to function, and I'll add the parentheses. I'm going to add another variable. I'm going to call this uppercase. So again, call your function whatever name you like, or your variables whatever name you like. So I'm going to set this variable to equals to this variable here that I've set to equals to this function. So I'll say my function, and then I'll add the method that will convert the text to uppercase. And next thing I want to do is return. So make sure when you are indenting, make sure your indentation is correct. So here on this second function here, I'm going to return the function, which is called wrapper. So our decorator function here takes a function as an argument. Okay, so next thing I want to do is define another function and pass that function to our decorator function. We will then assign the function to a variable and use that to call the decorator function. So let's create another function. To create a function, type in def, and I'm going to call this function say underscore hello. That's going to be the name of my function, and I'll just add the colon and I'll tab, and I'll add a return, and inside that return I want it to return a string. So I'm just going to, this is a string that's going to be converted to uppercase. So I'll say hello world. I want it to be all lowercase, so when it converts it, it will show that it's converted it to uppercase. Next thing I want to do is create a variable and then assign the function to that variable. So I'm going to create a variable. I'm going to call it decorate, and I'm going to set that to equals to my function, which is called my underscore decorate, this one here. So I'm assigning it to this function called decorator, and inside the parentheses for that function, I'm going to pass in this function here called say hello. So also say underscore hello. All right, so I'm passing in this function, and this function has this text called hello as the return value. So that's what's going to be displayed when it is called. So next thing I want to do is just get a print function to print that out on the screen. So inside the print function, I'm going to pass in the variable decorate, and that variable also has the function. So when I pass in this variable called decorate, you notice here I've included the parentheses as well. One more thing I need to do here on line 4, this variable here, I need to return it. I want the value returned, so I'm going to just tab down and add a return statement. So I'll say return followed by the name of the variable, which is called convert underscore to uppercase. So I'm returning that on line number 5, so that when that function is called, that will be returned. So now if I print out the content of this file, it should convert this text on line 9 to uppercase. So I'm using this variable on line number 10 to call this decorator function, and line number 11 here, we're just printing out the value on the screen. So if I hit the play button, you can see here it says hello world. So the conversion has worked. We've been able to use the function on line 4, which is the upper method. It's a string method that converts strings to uppercase. So it's converting the string that is returned on line number 9 to uppercase. However, Python provides a much easier way for us to apply decorators by simply using the @ symbol before the function we would like to decorate. So the short way of doing the decorator is that you attach the @ symbol before the function you would like to decorate, like I have done here. So by doing it this way, there's no need to create a separate variable to call the function. All right, so you can see here, I'm just calling this function, this function that says say underscore hello. I'm calling it, and you can see here I've applied the decorator to it. So by doing that, it implements the code that I have here. It calls this function here, which is the upper, and that's the one that converts this text into uppercase. So that's basically how decorators work. I've only just covered the very basics of decorators. To find out more, if you visit the link displayed on the screen, that's the official Python website that covers a more in-depth explanation about decorators. I'm going to introduce you to control flow in Python. What is control flow? A program's control flow is basically the order in which the program executes its code. So when you write code, you usually write it from top to bottom, and when the code executes, it should execute from top to bottom, left to right. But you can control the flow of that execution. Even though the code should execute from top to bottom, left to right, you can use control statements to control the order in which the code for the program works or flows. Control flow are very important. They help your program make decisions. The control flow of a typical Python program is regulated by several types of statements. So they're regulated by conditional statements, by loops, and by function calls. So let's take a look at the type of statements you can use in a control flow. The first is a conditional statement. Conditional statements are basically statements that will only run or execute if certain conditions are true or false. And they include if statement, elif statement, and else statement. We also have what is called loops. Loops are basically what you have in your programs if you want a particular block or aspect of your code to be repeated several times based on certain conditions. And the common types of loops are for loops and while loops. Also, you can have a function call in your program. A function is basically a piece of code that does something specific or performs a specific task. And the code you write with a function are normally reusable. A function call is basically when you call a function by its name and you get the function to execute the block of code that it contains. So to activate a function, you need to call it. And by calling it, it will then activate the code that it contains. An example of a typical function that we've used so far is the print function. I'm going to introduce you to if statements. If statements are basically conditional statements. That means they are statements that only execute based on certain conditions. If statements are important aspects of the control flow of a program. They help you make important decisions in your programs. They only run the code in the if block when the condition is true. So when you write an if statement, you'll have a block of code that you want to execute if the condition that you have set is met. So only that particular code will execute. If the condition is not met, then nothing runs. That code does not execute. If statements normally can use comparison and logical operators to check if certain conditions have been met or not. This is a basic syntax for writing an if statement. So you have the if keyword, and then inside that parentheses, you just specify the conditions. And then you have this colon here. This colon is very important. It tells the Python interpreter that you are starting a new line of code. So when you have this colon here, it indents. If you have a good text editor, it will automatically indent into a new line that enables you to write some new line of code. So whatever code you write here in the indented block, that is the code that will run or execute if the condition that you have set in the if block is met. To illustrate how the if statement works, I'm going to create a new file inside my Pycharm IDE. So I've already got a directory with some Python files. So I'm just going to right click on my directory and go new and click on Python file. I'm just going to call it if, and it will save it as a Python file with a .py extension. So I'll click OK. So now I've created a new file. The first thing I want to do is create a couple of variables. So I'm going to create a variable. I'm going to call it A. I'm going to give it a value of 7. I'm going to create another variable and I'm going to call this B, and I'm going to give it a value of 8. So I want to use the if statement to check for certain conditions before I can run what's inside this file. So I'll say if, A, and then I'm going to use an operator to check. I'm going to say if A is less than B, and now add my colon. The colon is very important. When I press enter, you can see it's well indented. Indentation is very important in Python. So if you're using Pycharm, it should automatically indent it for you. So now it's prompting me to enter a new line of code. So I'm just going to say print, and inside my print parentheses, I will just say the A variable, comma, and then I'll enter a text. I'll say is, and then I'll do a comma to exit that string, and then I'll say B. B here is referring to the value of this variable B. So once I've done, I'll just save my file. Now, what this will do, basically, I'm using this operator here, which is the less than sign, to check for a condition. The condition I'm checking for is the value of variable A is it less than the variable B. 7, which is the value of variable A, is less than the value of variable B. So the condition is true, and then this block of code will execute. Now, if the condition is false, nothing happens. The code will not run. It will just do nothing. So let me run this code so that you can see. I'll right click and go play. And you can see here is outputted 7, which is the value of variable A, is smaller than 8. Now, if the condition was false, nothing would happen. So if I reverse this, for example, if I change that to a greater than, that will make the condition false, because A, which is 7, is not greater than B, which is 8. So now let me try and run this again. You can see nothing runs. You see the code does not execute. This block here does not execute. Okay, so whatever code you have inside the if block, this here, well, I've got the print function, is known as the if block. So if the condition I set here is wrong or is false, this code will not run. The code will only run if the condition inside the if block is true or evaluates to true. So if statements are very important in your control flow. Always remember the indentation and the colon. Anywhere you see a colon here, you're telling the interpreter that you want to start a new line of code, and make sure it is indented. If it's not indented, the code will not run. The interpreter will complain. I'm going to introduce you to another type of conditional statement called else statements. What are else statements? Else statements are conditional statements that only execute certain block of code when a condition is false. So it is different from the if statement and the elif statement. Those condition checks for conditions that are true, while the else statements will check for conditions that are not true and then execute the block of code that it has. So this is what a basic syntax looks like for an else statement. So you start off with the if statement, which is the first conditional statement to check if a condition is true. You then go on to the elif conditional statement, which checks if another condition is true. Now, when the condition in the if and the elif are not true, it then goes to the else block and execute the code in the X block. So remember that with the if and the elif, this block of code will only activate or run if their conditions are true. Now, if those conditions are not true, it then jumps to the code inside this else block and execute the code if the code in the if and the else fails. I'm going to illustrate how the else statement works. So I'm going to create some variables. So I'll create a variable a and I'll give it a value of 7. I'll create another variable b and I'll give it a value of 8. I'll create one more, call it c, and give it a value of 9. So before you can implement an else block, you must have an if block in place. So I'll start with an if. So I'll say if the variable a is greater than the variable b, I'll add my colon and press enter, and that gives me the indentation. So now I'll write the body of the code that will execute if the condition is true. So I'm going to reference the variable a. So I'm going to say a, comma, and then I'll add a string, and that string is basically going to say if a is true, that condition, the text will say a is smaller than, I'll add a comma to escape that string, I'll say b. So now this condition here is my first condition. Don't forget the condition in the if block will always test for a true condition. Next, I'm going to add an elif block. So I'm saying elif if the variable b is greater than or equals to the variable c. I'll add my colon, I'll tab. The tab gives me indentation. Anytime you have a colon, you're telling Python that you're writing a new line of code to be indented against the block of code. So you know that each block of code belongs to a particular condition. So now I'm going to add a print statement. So I'll say print, and I'm just going to add something that will print. I'll say b, which is the value of the variable b. And inside that, I will add a string. I'll say b is smaller than, and then I'll escape that string, do a comma, and add the variable c. So this condition in my if block and in my else if block both have to evaluate to true for the code to execute. So this code here on line 6 is the if block code that will run if the condition set in line 5 is true. The code block on line 9 is what will execute if the condition set on line 8 is true. So if those both conditions are not true, this is where the else statement comes in. Then we want the code inside the else block to execute. So you add the colon, and I'll just tab, and I'll just do a simple print statement. Inside that print statement, I will say c, which is the variable c, and I'll add a text that will say is larger than. I'm going to escape that string with a comma, larger than b, and I'll do a comma, add another string, add and, I'll do a comma to escape that string, and then I'll add an a. So that is my code complete. When the code executes, it will check for all this condition. This first condition here is going to evaluate to be false because a, which is 7, is not greater than b, which is 8. So this block will not execute. So this block here is also false. B is not greater than or equals to c because b is 8 and c is 9. So this block of code again will not run because the condition is false. We then jump onto this block of code, which is the else block. This block of code will execute. There is no condition set. I've just said if these two conditions are not met, I just want this code to run. The code on line 12 is what will execute. So let me play that so that you can see the result. So if I press the play button, you can see here is printing out this code on line 12, which says 9 is larger than 8 and 7. The C is the 9, the B is the 8, and the A is the 7. So you can see only that code executed because the other conditions have not been met. So you only have one block of code execute. Anyone that matches the condition, that block executes. If, for example, this condition was true, the code will stop there. The other two, these two block will not run at all. If this block was true, it will stop here, and this block here will not run. So the else statement is an alternative statement that will run when the conditions you're testing for is false. I'm going to introduce you to another conditional type of statement called the elif statement. The elif statement is kind of like a bridge or a combination of an else statement and an if statement. So it's kind of like two types of statements combined to one. The elif statements are basically used to check for multiple expressions that are true in your program. So they check for several conditions that are true, and if one of them is true, it executes the first one it finds and then ignores the rest. So when you have an if statement will check if a condition is true and then execute the block of code inside that if block. And if the condition is not true, it doesn't do anything. A il or elif statement is kind of like multiple if statements. So it gives you options to check for conditions that are true. They will only execute a block of code as soon as one of the conditions evaluates to true. It will only execute that block and it will ignore the other code. So this is what a typical syntax looks like for an elif statement. So you start with the if statement, which will count as the first condition to check if it's true. And if it's true, you execute the block of code that is indented for that if block. If that condition is not met, it goes on to the elif block and checks for the second condition that is true. If that condition is true, it will execute the block of code under the elif condition. So it's very important to take note of the colon. The colon tells Python to execute a block of code. It also tells Python that you are starting a new line of code and the code must be indented. Indentation is important so that you know what code block belongs to certain condition. So let me show you an example of how the elif statement can work. So I've already got a Python file. I'm just going to create two variables. I'll create variable A and I'll give it a value of 7, and I'll create another variable B and I'll give it a value of 8. Now I can start with my if block. So I'll say if the value A is greater than the value B, and then I'll do my colon to tell Python that I want to start a new line of code. So I press enter and you can see it automatically indents it for me. So I'm going to type in a print statement. So I will say print, and inside the parentheses of that print function, I'm going to specify the code that will execute. So I'm going to say A, I'm referring to the value of the variable A, and I'll say you can type in anything you want. It doesn't really matter. is smaller, and then I'll exit the string with a comma. It's important you add your comma so that the interpreter knows the difference between a normal variable and a normal string. All right, so now this is my if block. So you can see by indentation, you can tell that this block of code belongs to this if block. So now I want to add an else block. You can add as many elif block if you want. So you don't necessarily have to have just the one. If you want to have several conditions to test for true, you can add as many as you want. So I'm saying else if, I'm checking another condition, if the variable b, let me reverse that. I'll say if the variable b, which is 8, yes, is greater than the variable a, I'll do a colon, then I want certain block of code to execute. So inside, I'll do a print statement, and inside that print statement, I will specify what I want. Then I'll escape the string and do a comma and say a. So this is my else if block. You can have as many as you want, depending on how many conditions you want to test for that are true. The code will check what's inside the if block first. That is a block that will run first. It's checking is the value of a, which is 7, is it greater than b? It is not. So that's condition. This condition is false. That means this code here will not run. So it jumps to this other condition, the elif block, and checks the condition. Notice I'm using the operators to check. This is a greater than sign. This is a greater than sign. There are many other operators, comparison operators and logical operators you can use. I've only just used the greater than just for simplicity, but depending on what condition you're testing, you use the appropriate operator. So this block in the if is wrong. That is, it has not tested true, so that code will not run. The code in the elif is true because b is greater than a. b is 8, which is greater than 7. So what will happen, this block of code will execute. So if I press play, you can see here, this code here that says b is bigger than a, b is 8, it says 8 is bigger than 7. So you can see that block of code executes, but the first one does not execute. So you can see the importance of the elif. So you can add as many elif in your code as required. I've only just used the one just for simplicity. I'm going to introduce you to while loop statements in Python. While loop statements are the type of statements that you add to your code if you want certain aspects of your code to run continuously based on certain conditions that are true. One thing you need to be careful of with the while loop is that you must make sure that the condition will eventually become false. If not, the code will continue to run and it becomes an infinite loop. So you need to set it up in a way that the loop can be terminated when the condition becomes false. You can also use an else clause or an else statement inside your while loop. So you can wrap the else statement inside a while loop. This is what a basic syntax looks like for a while loop. You basically have the while, and then you set the condition, and then you have the code that will execute. So let's create a while loop statement, creating an index variable, the variable that the while loop will use to get started. So I'm going to create a variable. I'm going to call it I, and I'm going to give it a value of 1. So now that I've got the initial variable set, this is the variable that the while loop will work with. So you start the while loop by using the keyword while, then you specify the variable, which is I. So I'm setting the condition now. I'm saying while I, which I set to 1, while it is less than 7, I'll add my colon. Then I will specify what I want to happen. So this is the code that will execute. Is going to print I on the screen. Now, the way the code is at the moment, if I stop here, this will become an infinite loop. That means it will keep running and it will never stop, because as it is now, the condition will always be true, because I will always be less than 7. So what I need to do, I need to use an increment operator to keep increasing the value by 1. So each time the loop goes around, I want it to increase it by 1 until it becomes less than 7. So what I need to do here, I need to say I, which is the variable, and I need to add plus equals to operator. What this operator would do, it will, each time the loop goes round, it will add 1 to it each time until this condition becomes false. So if it keeps going around and adding 1, eventually this will become less than 7, and then the loop will terminate and jump out of this block, and that will end the loop. But if I don't put this bit on line 5, then the code on line 3 and 4 will keep running and never stop. It will become an infinite loop. So it's something that you always have to be careful about when you are using a while loop. You need to make sure that at some point the code will become false. That is, the condition will become. So what will happen now, if I play this code, it will print out 1, 2, 6. I've got my code saved. I'm just going to play the code so you can see the output. What should happen, this code here on line 4 will print the numbers 1 to 6. It will not print 7 because the condition says as long as while this variable I is less than 7, I want it to print I. So what this code on line 5 does, each time the loop goes round, it will add 1 to it until it gets to 6. It then terminates the loop because the condition no longer becomes true. So let me play that. I click play, and if you look here, we can see inside my console I'm printing the number 1, 2, 3, 4, 5 and 6. It doesn't print 7. So that is the condition I have set. As long as I is less than 7, I want it to print I. So each time it goes around, it prints 1 because that 1 is the initial. It goes around the loop again, it repeats, and I add 1 here, it prints 2. It does the same thing again. Each time it goes around, it will print the number that has been added to the original value. So that's basically how the while loop works. But be careful when you're setting up a while loop. Make sure that it will eventually terminate by evaluating the condition you have set to be false. If you have a while loop that the condition is true all the time, the code will not terminate. It will keep running and running and running and running. So you really do not want that. I'm going to introduce you to for loops. What is a for loop? A for loop is a type of loop that is used to iterate over a sequence. So it will go through a sequence of items or values. The sequence is usually things like a list, a tuple, a dictionary, a set, or a string. So it has to be a collection that the for loop can loop or iterate through. The loop does not require an indexing variable. in order to get initiated, just like with a while loop. With a while loop, you need to have an initial indexing variable for it to work with. You don't need that with a for loop. Also, a for loop can use a break and a continue statement. So you can use those statements with a for loop. So let me show you how a for loop works. I'm going to create a variable which is going to be a list. A list is basically a collection of items or values. So I'm going to create a variable. I'm going to call it fruits, and I'm going to set that to equals to a list. And inside that list, I'm going to add some items. First item is going to be grapes. I'm going to add a couple more. Next, I'm going to add berries, and I'll do one more. And finally, I'm going to add oranges. So I have now created my list. So now I need to use a for loop to loop through the items in the list and print them out in my console. So to do that, you need the for keyword, type in for, and I'm going to just use a random letter. So I'm going to say X. So X basically is going to represent each item or each value in the list. So I'm going to say for X in the variable called fruits, I'm going to add my colon and tab, and I'm going to tell it to print X. And what that's going to do is going to print each item in my list on the screen. So let me press the play button so you can see the output. I'll click play, and you can see here in the list, you can see it has printed the items. I've got grapes, I've got berries, I've got oranges. So you got grapes, berries, and oranges. So that's what a for loop does. It iterates over a collection of items or a list, and then it does what you tell it to do. On line 4 here, I've told it to print the item. So X here represent each of the items in the list. So that's how for loop works. I'm going to introduce you to nested loops. A nested loop is basically a loop inside another loop. Let me show you a basic example of how a nested loop works. To begin, I'm going to create a couple of variables which are going to be lists, and we're going to be using a nested for loop. For loop are basically used to iterate over a collection of values. So I'm going to create two variables. First variables I'm going to create is going to be called colors, and I'm going to set this to equals to a list, and inside that list I'm going to have different values. I'll say green, that's one color. I'll do a comma, add another value. So I'll say yellow, that'll be my second value, and I'll add one more, and I'll make this a purple color. Next, I'll create another variable. I'm going to call this variable fruits. I'm going to give that a list value, and inside that list I'm going to add some values. So first it's going to be apples. I'll do a comma and add another one. I'll say banana, and I'll do a comma and add one more, and I'll make this one berries. So now I've created two variables which are list, and I'm going to use a nested for loop to loop through the values or the elements inside both lists. So the way it's going to work, I'm going to have the inner loop will execute once for each iteration of the outer loop. So let me show you how that would work. So to create a for loop, I'm just going to say for colors is the name of my first variable. I'll add a colon and tab to add a block of code. This is where I'm going to nest another loop. So I'll say for, I'll make this one y this time. I'll say for y in the variable called fruits. I'll add a colon and then tab. That gives me another line. And then I will add a print statement. I will say print. I want it to print the content of X and the content of Y. So what this will do when the code is played, the inner loop will execute once for each iteration of the outer loop. So every time the outer loop iterates or goes through the collection, the inner loop will be executed once. The way this code will work, the outer loop in this example is going to be colors, which is this one. So when the loop runs, it's going to print out on the screen. It's going to say green apples, green banana, green berries, and then we jump to the next one. It will say yellow banana apples, yellow banana, yellow berries, and then it will go on to the next color. It will print out purple apples, purple banana, and purple berries. So every time for each iteration of the outer loop, the inner loop will also be executed once. So let me play that and you can see. So you can see here it says green apple. That's the green is the outer loop here. So say green apples, green banana, green berries. So if I scroll down, you can see more iteration, and then it jumps onto the next element. So it prints out yellow apples, yellow banana, yellow berries, and then it goes to the final color, purple apples, purple banana, and purple berries. So that's basically how a nested loop works. So it's a loop inside another loop. What are modules? A Python module is basically a Python file that can contain various types of objects like functions, global variables, lists, dictionaries, and other types of objects. A module is like a code library. Creating a module is fairly straightforward. All you need to do is create a Python file, and then you add whatever objects you want into that file. So you can add a function, you can add a dictionary, you could add a variable, and any other types of objects you want to include in your module. So the first thing I'm going to do is create a new Python file. So I'm going to right click on my directory and go new, and I'll click on Python file, and I'm going to call this salute and click OK. So now I've created a new Python file called salute. So what I'm going to add into this file, I'm going to add a function and I'm going to add a dictionary. But you can add as many things as you want. So you can have several functions that do different things and other types of data structures depending on what it is you want to include. So let me start by creating a very simple function. So I'm going to create a function called say underscore hello, and I'm going to pass in one parameter, which is going to be a name parameter, and then I will add my colon and tab down, and I'll add a print function. So this is what will execute for that function. That's the function body, and inside the parentheses I'm just going to add a simple text that will say hello, comma, and then I will add a string which will be the parameter argument that is supplied for the name parameter. All right, so when this is called, you supply a name that will be appended to this text. Next thing I want to do is add a dictionary to this module. So I'm going to create a dictionary. So I'll say fruits, and I'll say equals to, and inside my curly braces, I'm going to add a key and then a value. So the key is going to be called name, and the value, I'm going to give it grapes. That's one. I'll do a comma and I'll add another key. This time I'll make this one color, and I'll add a value, and I'll give it a value of green. So this is just a very basic example of how you can create a module. So you can have as many things as you want, as many functions as you want, different kind of variables and other kind of data structures you want to include inside your module. I'll be showing you how to use a module. Once you've created a module, you can use the module in any Python file. And the way you do that is by importing the module. So you type in the keyword import followed by the name of the module. If the module has different types of object and you want to access just a specific object inside that module, you can represent it by using the from keyword. So you type in from, you specify the module name, and then you import what you need from that module. So this is a module that I created in a previous video. It's called salute.py. It contains a function and it also contains a dictionary. So what I'm going to do is create another file and try and use this module by using the import keyword and also the from keyword. So let me create a new file first. So I'll right click and go new. I'll click on Python file, and I'm going to call this my underscore module and click OK. So that's created a new Python file for me. So the first method I'm going to use to import a module called salute, which is this module here. I'm going to import that module into this file. And to do that, you need to add the import statement. So you do import space followed by the name of the module. My module is called salute. To use the function inside the module, what I can do is just call the module by its name. So I'll say salute dot, and then I reference the name of the function, which is say underscore hello, and I will pass in a variable for the parameter. So I'm passing in an argument for the parameter inside that function. So before I run this file, let's take a look at the module. So this is what the module is. It has this function, which is what I am referring to, and there is a parameter inside that function called name. So all I need to do, I don't even need to use this print statement here. I'm just referencing it from this file, but the only thing I'm doing different is I'm passing in an argument for this name parameter. Okay, so all I need to do now is just play this file and it will output hello blue line. So I click on play. You can see here it says hello blue line. So this is an example of how you can use a module by importing it into another Python file. You can also access a module's objects by using the from keyword. So what you can do, you always do the import at the top. So you can say from, which is the keyword. Then you specify the name of the module, and then you specify what it is you want to use from that module. So let's say I want to use the dictionary called fruits. So I'll say fruits. All right, so this is the module here. You can see I've got a function. I've also got a dictionary called fruits. So that's what I'm referencing in this file. So what I'm going to do, I'm going to comment out line number 1, so that, and also line number 3, so that we can see how to use the dictionary from that module. So let's say I wanted to access one of the keys from the dictionary inside my module. So you can see this is a key called name. All I have to do, I'll just come here and can just say print, and inside that print function I can reference the name of the dictionary, which is fruits, and inside the square bracket I just add the name of the key, and that should print out the name, the value for that key code name. So if I press the play button, you can see here it's giving me the value of grapes. If we go back into the actual module itself, you can see here the dictionary called fruits. I've got a key called name, and the value is grapes, which is what I have referred to here on line 5. So there are 2 ways you can access a module. If you want to access the entire module, you just do import and then followed by the module name. If you want to just use parts of the module, like I've done here on line 2, you use the from keyword. So you say from, then the name of the module, and then you import what it is you need from that module, like I've done here on line 5. So I've just referenced the fruits, which is the dictionary inside that module. Okay, so that is how you can use a module once you have created the module. What are built-in modules? Built-in modules are the modules that Python has already created for you. Before you can use the built-in modules, you need to use the import statement to access them. I'm going to show you a couple of example modules that are built in that we can use. The first one is a module called random. This module is basically used to generate random numbers. We can use the module, we have to import it. So you do that by using the import statement, which is import, and then type in the name of the module. The module is called random, and it is used to generate random numbers. Say for example, I have a variable called x, and I set it to equals to random, random being the module. So what this code on line 3 is basically x is a variable I created, and I've set it to equals to the module random, and inside that module random I am using a function called random. All right, so what I can do, I can print this out on the screen by using a print statement. I can just say print, and inside the print function I can pass in x, which is the value of this, which is this x variable, which will give me a random number. So let me click on the play button, and you can see here is giving me a random number. If I click on play again, the number will change. You can see it's giving me another one. If I click play again, it changes the number it generates. The number it has generated is basically a float. So a float is a number that has decimal. Now inside this module called random, it has other functions as well that one can use. One of them is called randint. What that does, it can round numbers into an integer, which is a whole number. So if I want to say generate a number that will be a whole number, I can, for example, create another variable if I want to. So I'll just create a variable y, and I'll just set it to equals to random, which is a module. I'll do a dot, and then from that module random, I'm going to use a function called randint, which is what will convert whatever random number is generated into an integer. So I'm going to pass in two values, 0 and 50. So what that will do, it will generate random integer number from 0 to 50. So for that to happen, I need to add a print function and pass in the variable y into that print function. Now let me play this and then you can see. So this is the first one. That's the first print on line number 4, where it generates a random number, which is a float. And then line number 6 here is where I use the randint function. Line number 7, I'm telling it to print y. So that's it there. So what that does, it generates a random number and then converts it into an integer. So any random number between 0 and 50. So if I click play again, it will give me a different number this time. You can see it's giving me 47. So any number between 0 and 50. So when you're using the randint, you can always specify the range you want it to generate from. There's another module I want to quickly introduce you to. It's called the platform module. It's used to basically detect what platform your system is running on. So to use it, again, we need to import it. So I'll type in import space followed by the name of the module. Is called platform. So now that I've imported it, I can use it in my file. So I'm just going to create a variable called j, and I'm going to set it to equals to platform dot. So from the platform module, there's a function called system. So I'm using that function called system, and I'm just going to attach a print statement. So I'll say print, and I'll pass in the variable j. Now if I print that, it should tell me what platform I am running on. So I click on play, and you can see here it says Windows. All right, so if you're on a Mac, you should say Mac, and so on. So that's how you can use built-in modules. You first of all have to import them, and then you can access either different parts from that module that you want to use. So what are packages? In Python, packages are basically folders or directories that contains modules. They also contain a special Python file which is called init.py. So it has a double underscore on either side. The init.py file can be empty. The file basically is used to tell Python that the directory or the folder contains a Python package which can be imported just like a module. The packages are a convenient way to organize your modules, and they can also be nested in each other. So you can have a package inside a package. Creating a package is fairly straightforward. If you're going to do it manually, you create a directory. Inside that directory, you create a Python file and name it underscore underscore init underscore underscore .py. When creating a package using the Pycharm IDE, it automatically adds the init file for you. So let's create a package. So I'm going to right click on my directory here. I go new and I go Python package, and I'm just going to give the package a name. I'll just call it healthy. That's the name of my package. I'll click OK. So I've now created a package called healthy. And you can see this Pycharm has automatically added this init init.py file. So you can also nest other packages. So if I wanted to create another package inside this package, I just right click and go new and then add the Python package, and that will automatically add another init.py file. So once you have created a package, you can add any number of Python files into that package. So what I want to do, I want to create a module inside this package called healthy. So I'm going to right click and go new and go Python file, and I'm just going to create a module. I'll call it foo, FOO. So that is the name of my module. Now inside the module, I can add a simple function. So I just say def, and I'll call the function, say, fruits. And inside the parentheses, I can just pass in a parameter, which would be a name that you supply for the fruits. So I'll tap down and I'll just add a print statement. Inside that print statement, I can just say, reference the name parameter. I'll do a comma, and then I will just add a text. We'll say name, and then you say whatever name you pass in as the fruit. It will say, if for example you pass in the name of apple, it will say apples are good for you. So this is basically a module that I've created inside my package. So if you look at this foo here, which is a module, is nested inside this package called healthy. Once you have created a package, you can access the module within that package the same way you would access a normal module, by using the import or the from keyword. So before you can use a module, you have to import it. Now my module that I'm trying to use is inside a package. So I'll need to type in import, followed by the name of the package, which is called healthy. And then I'll add a dot, followed by the name of the module. So I've now imported the module I want to use by first adding the name of the package, and then I use a dot followed by the name of the module. So now I can then access the content of the module. So the way I can do that, I can just say healthy, which is the name of the package, dot foo, foo is the name of the module, and then dot again, which is the name of a function inside that module. And I can now pass in a value, which is an argument for the name parameter inside this function called fruits, which is inside this module here. So this is what I'm giving the value for inside here. I've given it a value of apples. So I'm just going to save my file. Now if I play this, I should get a response. It says apples are good for you. So if we go back into the module I created, this is the module for the package, and this is what it's printed out, the name, which is what I have supplied. I've supplied apples, and then it appends that text to it, which is this. So this is one way of accessing your module. Another way to access a module is by using the from keyword. So what I'm going to do, I'm just going to comment out line 1 here so that that code does not run. And here on line 3, I'm going to add the from keyword. So I'm going to say from the package called healthy, I want to import the module called foo. All right, so that imports it. And then on line 5, I can modify this code here. All I need now, I don't need the healthy bit here. I can just remove that and just reference the module directory. So I'm accessing the function called fruits, which is inside this module called foo. So now if I save that and run it, I should get the same output. So I click on play. You can see it gives me the same thing. Apples are good for you. So the two main ways you can access a module: you use the import, or you can use the from keyword. First thing you need to do is open up the Python shell. So the way you access it is via the Python folder. So if you go into your programs file, there's a Python folder, and just click on the idle, and that will launch the shell. So once you've got the shell open, we need to open up a new file. So click on File, New File. And this file here is where we will write the code that will build the calculator. The first thing I'll recommend you do is save this file. Save it as a Python file. So you do save as, and then give it whatever name you want. It's already got the Python file format here, so you don't need to worry about that. Just give it a name. I'm going to call mine calculator. And I just press save, and that will save it. I want it to save on my desktop, so I click save. So this file now is a Python file. The first thing I want to do is import a library. The library I want to import is called tkinter. It's a library used to generate or create graphical user interface. So to do that, we need to import it. So you type in from, then you specify the name of the module. So this is a module, it's called tkinter, space, and type in the word import, space, asterisk, and that will import the library into the application for me to use. The next thing I want to do is create a class. A class basically is a template for creating objects. So I type in class, followed by the name I want to give the class. So I'll call it application. And when you create a class, you can also pass in arguments or parameters into it. And I'm going to pass in a frame as an argument into that class. And when you create a class, you also have to put a colon there. So this will be the main class for the calculator. Notice I've passed in frame there. A frame basically is used to group and organize other widgets. So it's kind of like a container object for all the widgets the application is going to use. So inside this class, I'm going to create a function or a method. So to define a function, you type in the word def followed by the name. So I'm going to use the init. So you do underscore init underscore, and then in parentheses is where I'll pass in any arguments I want inside that function. This underscore init underscore function is a special function that is called when an instance of a class is created. So you use that to initialize that instance. So inside the parentheses, I'm going to pass in two arguments. I'm going to pass in a self variable and master. The self is a reference to the current instance of the class. Okay, that's what that self is. And then the master represents the parent widget. So now let's initialize the frame. So to initialize the frame, we're going to use a special built-in function. And the built-in function is called super. So inside the parentheses, I'll pass in some values. The super function is a built-in function which returns a proxy object to delegate method calls. So it uses that to delegate method calls to a class, which can either be a parent or a sibling in nature. So inside the super function, I passed in the application class here, and also a reference to the self variable, and here I'm using the underscore init again to initialize the master widget. This master also is known as the parent widget, so we're initializing it here. To save time, I've added a few lines of code here. So I've added these lines of code. So the self again is a variable that it's a reference to an instance of a class or an object that is created. So here I'm setting this to blank, and then here I'm using the self again dot user input. This is going to be a user input variable, and I've set that to equals to the string var. Basically, this string var is going to hold a string, and the default value is blank, but I've set this to make sure it holds a string value. Then here we've got the grid method. The grid method basically is used to register a widget with the grid geometry manager. So if you don't do this, the widget will exist internally, but it will not be visible on the screen. So the grid is used to register widgets with the geometry manager. The geometry manager is used to manage the placement and the layout of the elements of the GUI. The create underscore widget function, which we'll use to create widgets. So let's create a function that will be responsible for creating our buttons for the calculator. So to create a function, you do def space followed by the name. So I'm going to call it create. I'm going to use this here, create underscore widgets. So there will be widgets, and I am going to pass in self, the self variable, into that function. And inside this function is where we define the various buttons. The user input is going to be stored as an entry widget. So inside this function, this create function, we are going to make reference to the entry widget. To save time, I have added some line of code here to the function that I created. So here we've got a reference to the self variable dot user underscore input, and we're setting this to equals to entry. This refers to the entry widget. The entry widget is basically used to accept single line text strings from a user. If you want to display multiple lines of text that can be edited, then you need to use a text widget instead. If you want to display one or more lines of text that cannot be modified by the user, then you should consider using a label widget. So here we're using an entry widget to accept a single line text strings of input from the user. And here we passing it, this is the background color, BG reference to background color, and this is a hex value I've given it. You don't have to use hex value, you can just type in the color you want. If it's brown, white, but enclose it in quotes. And here we're referring to the border. BD stands for border. So the default value is usually in pixels. So I'm setting the value here to 29. So this will be the size of the border. And the value is in pixels. And here we're inserting the width. We're setting the width to 4. So there's a difference between the insert width and the actual width. The insert width basically is the width of the insertion cursor. So it references the height. So its height is determined by the tallest item in its line. The default value is usually 2 pixels. But I've set it to 4, and here the width basically refers to the width of the widget in characters, not pixel value. And it's usually measured according to the current font size. And here we've got a reference to the font. So the font I've specified to use is Verdana. When you specifying values, you need to enclose them in quotes if they are text or string values. And this 20 here refers to the size of the font. Bold means I want it to be bold. Here we've got a text variable here, which I'm setting to equals to the self variable.user input, and I'm using the justify here to justify its position to the right. And here we are using a grid method for the input, and this is the column span for the grid. And on the screen of the calculator, we are setting a default value of 0, so the calculator will have 0 on the screen as a default. So I have now added a value here. This is for the button. So I've started, this is the code for the button here. So this is going to be the number 7 button on the calculator. So this is the piece of code I've got for it. So here again, we're referring to it as button1.self. This will be the variable, and I'm setting that to equals to button. And inside this button method, we've got reference to the BG, which is a background color. I've given it this as a background color, and that is the border. I've set the border size to 12. Usually it will be in pixel values. Text, this is a text that will appear on the button. It will have number 7 on it. This PADX refers to external X padding. So this dimension is added to the left and the right outer or outside of the widget. So the dimension you apply to the left and the right outside of the widget. So that's what you use for the PADX. So this is the value I've given it. And next to it, we've got PADI. PADI basically is for external Y padding. Y, this refers to the padding on the X-axis. This PADI Y refers to padding on the Y-axis. So it's basically external padding. And the dimension is added to padding above and below the widget. And here we've got the font. I've set the value of the font to Helvetica, and the size is 20, and I've made it bold. Here we've got command. We set that to lambda. Lambda basically is an anonymous function. So it's a keyword used to describe an anonymous function. So here we've got a self button.click. We've not defined this method yet, but we are attaching it to this here. So later, once we create the button and once we write the function for this button.click, when someone clicks on the number 7 button, it will fire off the logic inside this button.click method. And here we have got a grid with row of 2. The row number, basically this refers to the row number into which you want to insert the widget. So the counting starts from 0, and the default is the next higher numbered of unoccupied row. So it basically refers to where you want to insert the widget. and I've said I want to insert it after the second row. The column number basically refers to where you want the widget to be gridded, where you want the grid to apply. This column here, okay, I've set it to equals to 0, which is the default. I've also set the button here with a value of sticky. Sticky, basically this option determines how to distribute any extra space within the cell that is not taken up all by the widget. So any extra space that the widget doesn't occupy is sorted out using this sticky. So it will distribute the extra spaces. If you do not provide a sticky attribute, the default behavior is to center the widget in the cell. So I've given it a value of W. What that will do, it will stretch the widget both horizontally and vertically to fill the cell. So this button is the number 7. All the rest of the buttons are going to be identical. So what I'm going to do, I'm just going to copy this piece of code here and just change the relevant button number. So I've added the other buttons that the calculator will need. So this was the one we did together, number 7. So basically the code is the same. All I've done, I've just changed the text number. So this will now be button number 8, and this will be button number 9. This will be button number 4. This will be button number 5. This will be button number 6. So let me scroll down so you can see the other buttons. This is text button number 1. Say this is 2, 3, and 0. This will be the addition button. This will be the subtraction button. And this will be the multiplication button. And this is the division. The division is you do division with a slash. That's how you identify division in Python. So you use a slash. Most programming languages actually, you use the slash to indicate a division. And also I've got the equals to button. So when you do the calculations, you want an equals to button. So this is the equals to button here. And I've also got a clear button, which I'm going to have the text set as AC, so you can clear what's on the screen. So that is all our buttons that we're going to need for the calculator. Before we carry on from where we stop, I just want us to quickly look at the code we have so far. So we started off creating a class. Then we have a few functions here. We created a function called _init. We initialized the frame. So the master here basically is the main window of the application. We had created a class called widgets, and here we have the different buttons created as widgets. So most of the code within the buttons are the same. The equals to button, this is the equals to button here. Here we have where we've got the sticky, set the sticky to equals W. We've got the column span to 2. Normally when a widget occupies one cell in the grid, you can also grab multiple cells of a row and merge them into one larger cell by setting the column span option to equals to the number of cells. So we've used the column span here, and also here we've used a command. Notice we didn't use lambda there. Here we've used a command, and we've set that to self.clear display. What this will do, when you click on the clear button, it will clear the display on the screen. So that's what that will do. Also here we used the self.task and we've set that to blank. Basically a task is a subclass of future, of a future. A future basically is an object that is supposed to have a result in the future, and the task is a subclass of that future. So let's go ahead and create a few more methods of function. During the creation of the buttons, we attached it to the button.click method, which we haven't created. So I've now created it here, and the button.click method here. So it takes in the self variable and the number that the user inputs into the calculator. So here, this is the logic. So we're doing the task.self. We're setting that to str.self. This here is a special string class, str. And inside the parameters here, we've got inside the parentheses the self.task plus the str and then the number. Str is a special string function class. Okay, and here again we're using the we're using the self variable dot the user in, and we are setting that to this self.task. So this is for the button click method. So when they click on the button, it will kick off this logic inside this code here. So take note that this str we have used is a Python built-in string class. It's a string class which is a built-in function, built-in class in Python. It's a built-in class called str. It's a string, built-in string class called str. I've created another function here called calculate task. Again, I passed in the self variable here, and this function I've also attached some error handling. Python allows you to implement errors and exceptions to be handled by your program. So it allows your programs to handle errors and exception. In order to do that, you need to use both the try and the except statement. So here is my try statement, and this is what I've specified, and here is the statement for my except. So this try and the except are there to handle any errors in the application. So basically what this is doing here, this function here, any data that is passed into that variable, it's going to be any input. So it's taking the input, is getting the input from the user and then passing it into this variable here, and it will catch any errors here using this try. So if the answer evaluates 2 equals to that, it will display. If there's any error, the error will be captured. Okay, so this here is used to display the text of the answer, and this also self.answer will display any task that's been inputted. And here it's a syntax that will capture any invalid syntax you enter or any error messages. It will be captured there. I've added 2 other functions here. This one here called display text, and passed it the self and then the value that the user inputs. So again, this is what it will do. You takes in the input from the user, and if you decide to delete your entry, these are the parameters it will take. And if you're inserting, this is a code that will handle the insert. Again, this is a function. This function is responsible for displaying the text. This function here is responsible for clearing the display. Okay, so any input you enter here, you can clear it using this piece of code there. So here in this bottom here, I've added this here. So we're setting the calculator to equals to this tk method, which we specified earlier on, the tk root. So we are here with this title, we're using that to set the title for the calculator, and this is what we'll call it. Okay, this tk here is a root, so it's saying that the root of the application will be the calculator. And app, the app here is refers to the application name. This is the name of the application. It's called calculator. This here, you use that to make the window a fixed window, so the window cannot be resized. Okay, so hence I'm setting the height to false, so you cannot resize the window of the calculator because of this line of code here. And this is the main loop of the calculator. This is the event loop. This is what keeps the calculator running until you exit the calculator. So that should be it. So I'm just going to click save. So let's do a quick review of our code. Make sure the code is also formatted properly. If your code is not formatted properly and you try to run it, it can cause syntax errors and the editor will complain. So make sure you've got it structured the way I've structured mine. I've also added some comment here. So anything you see here in green here, these are all comments. When you run the application, the comments are ignored. Okay, so these are comments, and also this here is a comment. Anywhere you see the hash symbol is also a comment. Okay, so these are all comments. It just helps give you a description of what we've done here. So this tells you here that this is the main class for the calculator. It tells you here we are initializing the frame. Here we're creating all the buttons for the calculator. Here the user input, we're storing them as an entry widget. Here is the button for value number 7. In here we've got value number 8. So these are all comments. Anything you see a pound sign is a comment, and so on. So I've commented out, just put a comment before each line so you know what they do. Okay, so make sure your code is formatted this way. In here there is a format option to indent your code, so if you know it's not indented properly, make sure you do that so that the editor doesn't complain. So you notice within the functions, you see where the function is created, and then the other actions, the logic inside the function, there's indentation. You can see that. Even with the class, you can see the class, the indentation from the class, and the methods. If I scroll down, you can see the indentation also. Okay, see how it's all indented. All the logic is indented underneath the respective methods. Okay, so make sure it's all sorted and structured in this way. So once you've done that, you just click and save, and let's try and run the application. So we click run and do run module. Hopefully, yep, okay, that's good. So this is the application here. Let's see if we can do some calculation. So that's 8 times 8, that's 64. We'll clear that. 9 plus 9, 18, we clear that. 56 minus 8, we clear that. So all the, what one have we not used? Let's do a division. We do 82 divided by 6. Okay, clear that. 9 divided by 3, clear that. So we've got all the buttons and the functionality working properly. To begin our development, you need to open up the Python shell, and you can access it via your programs menu. Inside the Python folder, there is the idle. Just double click on the idle and that will open up this shell. So once you've got the shell open, we need to open up a new window. So you go File, New File, And inside this area here is where we'll develop our application. So the first thing you need to do is save the file. So you do File, Save As, and you can save it anywhere you like, but just save it with a .py extension. Actually, you don't need to, because it's already done that for you here. All you need to do is give it a name. So I'm going to call mine Count Down, and I'll just save it, and I'll save it on my desktop. Okay, that's it. So I've got the file. So this now is a Python file. I want to use some Python libraries, so before I use them I need to import them. I'm going to import tkinter, which is a module that is used to create user interfaces of various types. So to import that, I just need to type in from space tkinter I can't spell today. Kinter, that's it. From tkinter, then you type in the word import space asterisk. So with the asterisk it will import the library. Next we want to import another library. It's also a subset of tkinter. So do tkinter space import space, this one's called ttk. Next we want to import a tkinter font, so we can use a font from tkinter. You type in the word import followed by what you're importing. So we're importing the font element. Next I want to import the time module, so I just type in import time. Also want to import the date time, so I type in import date time. Alright, so I've got all my libraries and class methods ready. First thing I want to do is create a variable. It's going to be a global variable. A global variable means it will be available throughout the application. Python variables are scope based, so you can have a variable that is local or exists only within the module, but by declaring it global, that means I want it available throughout the application. So I just type in the word global followed by the name I want to call it. I'm going to call it end time, so we'll use that later in the application. So I want to create our first function here, and to create a function you type in def followed by the name. I'm going to call this count underscore weight. That's going to be the name of my function. Actually, before I create that function, I want to create another one first. I want to create a function called quit. This will allow us to quit the application, and inside the parentheses I'm going to pass it arguments. Okay, and that's it, and semicolon. You use the asterisk and the args, which stands for argument. So what you normally do when you're not sure how many arguments might be passed to your function, you use the asterisk and X. What that does, it allows you to pass an arbitrary number of arguments to your function. And inside this quit function, I'm going to add a root method. So I'm going to say root dot destroy. And what the root dot destroy does, it will cause the main loop of the application to exit. So when the application keeps running and if this function or this method is called, it will exit the application from the loop. One more thing I want to do before we wrap up this video lecture, I want to create another function. This time I'll call it can't underscore wait, but feel free to call yours whatever you like, and then the parentheses and the colon. And I'm going to create a variable, and I'm going to call this variable time left, and I'm going to set that to equals to the end time variable, which is this variable here, the global one. So I'm setting it to equals to that minus the date time dot datetime dot now. This is a method, a time function. We've imported the datetime and the time module, hence we're able to utilize it here, and this will give us the current time. So if we take away the value of this end time from this method here, it will give us the time left over for our event. I have added some more line of code so as to save time. So I've added this line here. What this does, it takes away the microseconds. Okay, so if without that, the time will display after the seconds, it will also show some microseconds. So I'm using this value here to take away the microseconds so that we don't have that displayed. And then here I've created, this is what will display the clock. Okay, this will show the time that is left to your particular event. This is what we've used to set that time. And this here, this piece of code here, is used to trigger the countdown after 1000 milliseconds. Before I carry on, I just want to elaborate on some key differences between the tkinter, this one, and the tkinter import for the ttk. All right, the difference is a lot with the widgets. With the widgets in tkinter, they are highly and easily configurable, so you have almost complete control over how they look, their border width, the font, the images, the color, and so on. The widgets that are controlled by ttk, they use styles to define how they look, so it takes a bit more work. If you want a non-standard button, then ttk widgets are also a little bit more, they are more difficult to configure. So they're both run under different types of engines. So generally speaking, the theme widgets that makes your application look more elaborate and more elegant, you get that with ttk, but the ttk are less configurable in comparison to tkinter. All right, let's carry on. So we're going to create, say root is equals to tk. The tk method or function, what that does, it creates a root. So everything that you put on the screen, whether it is a text box, a button, or an image is referred to as a widget, and they must all be placed in the root. So you can think of a widget like think of the root as a basket that you put all your widgets in. So now that we've got the root sorted, let's try and add some properties. So we are going to say root dot attributes. I'm going to set the attributes, and this is relating to the screen. So we're going to set how we want the screen to be. So you do double quote dash full screen. If you want your application to be full screen, then the value, you have to set the value to true. I want to be able to control how the screen looks, so I can resize it. So I'm setting that value to false. So I want to set up the background color for the main screen. So you do root, which is the main window. So the root dot configure, and inside parentheses you type in the word background, background. I'm going to set the color to black. And close the parentheses. The next thing I want to do, I want a button like this X button to be on the application, and I'm going to bind that to this function here called quit. So when you click on that X, it will quit the application. So I do root dot bind, and inside the parentheses for that method, I am going to do a double quote and then the X. So this will be the X on the screen that you can click on, and the other argument I'm going to pass in is the function called quit. Okay, so I'm passing that into there as well. Next thing I want to do is call the function. This want to trigger the clock. So we do root to call the timer again. So we want the timer to start again here after 1000 milliseconds, and we're passing the can't wait function. Okay, so we specified it here. We're doing that again here. So this is called here once the screen is activated. So we are now going to set the end date when we want our event to end. So we're now going to set up the end date so we can start counting the time. So we created a global variable here called end time. So I'm going to use that now. So I'll say end time. I'm going to set that to equals to the date time dot the date time method, and inside that method, in between the parentheses for this method is where I will specify when I want my event to end. So you start with the year 2017, followed by the month is the 9th month, followed by when I want it to end. I want it to end at the end of this month, so I'll say 30th, Okay, and then you pass in 0 just to format it, and 0. So if you have a month that doesn't end in 31, that has 30, for example, if you put 31 and you know that September only has 30 days, it will throw up an error. So this here, the first 0 will represent the hours, and the second 0 will represent the minutes. So now we've set a value for our end time variable here, which is going to equals to be the date time, and inside this date time module we have a method called date time, and we're passing it a value of the year, the month, the day, and then the time. This first 0 will represent the hours and the seconds, and the other one represents the first 0 represent the hours and the minutes, and the other 0 represent the seconds. We imported the font from Tkinter, so let's try and use that as well. So to use that, we are going to create a variable. So here I'm going to create a variable called fnt, which is short for font. You could call it anything, doesn't really matter. We're going to set that to font dot font, and then inside the parentheses of this font method we are going to pass in several properties. First, we want to pass in a font family, and we're going to pass in a font called Helvetica. Okay, and next thing we want to do, we want to give the font a size. So I'm going to set this to what shall I give it? I'm going to make this 90, and I want it to be bold, so I'll say weight equals bold. Weight means how thick you want it to be, so I just set it to bold. Oops, I've got my quote outside of the parentheses. It should be inside. To save time, I have completed the rest of the code here. So we've already covered this one. This is where I set a new variable for the font and passed in these values here. This will be responsible for the size of the clock of the tick. Okay, that's the actual, that will control the size of the text on the screen. Here I've defined a variable called text. When you define variable, you can always change the values. So this variable here, I've set it to equals to string var. What that means is that this will accept string values. So the values that will be passed into this variable is going to be string. And here we've got a label, and here I'm using the TTK module, this one here, and the label I'm using here for the label, which is the root, that is the root of the application. I'm setting a text variable to equals to text. I'm setting the font to equals to this font here, the variable. The foreground color, which would be the color, not the background color, the color at the front will be white, the background will be black, and here, this here is used to position the clock on the screen. This anchor here positions it in the center, and this two here, real X and real Y, are used to position the X and the Y axis. And then here we've got the root.main loop. So this keeps the application running. So this is what keeps the clock running until you exit it. So it handles the event loop. Okay, so each time the event loops, it handles it and it keeps the application running until the window is closed. And when the window is closed, it usually calls the quit function here and then exits the application. So that should be it. So I'm just going to save this. Make sure that you format your code just like I have. If not, this editor here will complain. Is very fussy. It likes its code to be formatted in a certain way. So if it complains, just respond by formatting the code properly. So this is it. So I'm just going to test to run the application. So I'm going to click run module. Okay, that is it. So it tells me I have 22 days left. 22 days, 7 hours, 58 minutes and 53 seconds left to my event. So you can always change the value of when you want your event to end. So that's it, how you create a countdown timer in Python. I'll be showing you how to create a very simple program in Python that you can use to simulate the generation of lottery numbers or just 6 numbers. The concepts that we're going to use in this program include importing a module. So we're going to import the random module that contains functions that will let us generate random numbers. Also going to create a list. We're going to be using loop, so we'll be using the for loop and also a while loop. We're also going to use a function from the random module called randint that is used to generate random integers. An integer is basically a whole number. We're also going to be using some functions from the list. So we're going to be using the append and the sort function from a list. We will also be using the print function to print out the random numbers that have been generated. We are going to also use a range function. A range function is basically used to return a sequence of numbers. I'm going to be using Pycharm, which is a Python editor or IDE. So this is my Pycharm IDE. I've already got a directory where I have some Python files that I have been using. So I'm going to create a new file inside this directory. So I'm going to right click and go new and type in Python file. I'm just going to call this lottery and it will append it with a .py extension. So this is it here, just created. The first thing I want to do is import the module called random, which contains functions that I would use to generate a random number. So you type in import space and the word random, and that imports the module called random. Next thing I want to do is initialize an empty list that will store the 6 numbers that will be generated. So I'm going to give the list a name. So I'm going to call it lottery underscore numbers, and I'll set that to equals to an empty list because nothing is in the list at the moment. I just want to initialize the list. The next thing I want to do is add a for loop and specify a range. So I'll do for I in range, and for that range function I'm going to pass in 2 parameters. We go 0 and 6. So what that means, it will generate 6 numbers from a list that the randint function will pull from. So that is the for loop, and inside that for loop I'm going to create a variable called number, and I'm going to set that variable to equals to random. So I'm referencing the module called random, and from that module called random I'm going to use a function called randint. That's the function that will generate the random numbers, and inside that randint function, and we need to give it a range of numbers to generate from. So I'll give it 1 to 50. So what that means, it will pick out 6 numbers from 1 to 50, because inside this range I specified 0 to 6. So it will, from this block from 1 to 50, it will generate any random 6 numbers. And I want to add a while loop. While loop basically will execute a set of statements as long as a condition is true, while the for loop is used for iterating over a sequence. So the for loop will be used to looping through the sequence and then print out any 6 numbers that was generated. So I'll say while the variable called number in the variable called lottery underscore number, which is the list, and I'll add the colon here. So this is, and then the code I'm going to write, just notice the indentation. So any code under here will be the code for the while loop to execute. So I'll say while the number is equals to random dot randint, and then again that randint is 50. So as long as it keeps generating 6 numbers from this block, anything from 1 to 50, so those are the condition. All right, and then I need to indent. Indentation is very important so that your code will execute correctly. So notice my indentation here, this one is on the same level as the while loop. So now after the while loop, I want to be able to, any number that is being generated, I want to use a list method called append to drop that number into this empty list I created on line number 3. So what I'll do lottery underscore numbers dot append. Okay, so this will append any number that is being generated, and I'll pass in the variable called number, which is this variable here. All right, so this append drops any number that is randomly generated into the list. And then I'm going to indent another level. So notice that this here or here, this lottery here, whatever number gets appended here is for this for loop. So all this code here are under the for loop. So now you can see I've indented. So this indentation is on the same level of the for loop. So what I'm going to do now is, now at this stage, all the numbers have been generated, the 6 numbers, and they would have been appended to the list. So what I need to do now, I want to sort it so that the numbers are sorted inside the list. So to do that, I'll do lottery underscore numbers dot sort. So this sort method will sort the items in the list. And the final thing to do here is just to print out the outcome on the screen. So we do lottery underscore numbers, and that will just print out whatever number was generated and placed in the list. Okay, let's run the code and see if it works. So each time you create a new Python file inside the Pycharm, you have to right click and run the file before it shows up there. All right, so click on the play button, or you can right click and click run whatever you've called your file. So I'm going to click on this, play, and you can see here it's generated 6 numbers, and you can see it's sorted them in that order, 2, 17, and so on. So let's generate another one. Click on play again. You can see it's generated a different set of numbers. I'll do one more, play, and you can see. All right, so this concludes the little program that will generate random 6 numbers, which can be used to simulate lottery numbers or other type of numbers that you're trying to generate.